Check, check. All right. You guys all ready? Sound is good? Do you hear me well?
Yeah, great.
Okay. Video, everything? We're good? All right. Awesome. Well, welcome early in the morning. My name is Daniel. This is the first workshop of the day at Dappcon. Super happy to be here. I hope I can get you excited about the stuff that I'm talking about today. It has a long title. I actually decided to keep it a bit more simple. So I wanted to talk about deploying your application once and using it everywhere. The original title was Crossing the Interoperability Bridge, a deep dive into building interoperable dApps with IBC. But one big, I guess, message I want to bring across today is that we're building a lot of really deep core technology, but in the end of the day, we really actually want to keep things simple. So I'm the CPO at Altiplanic. This is the core contributing company to Evmos, the Evmos Foundation or the Evmos chain. Has anybody heard of Evmos here before? Okay, quite a few, okay, majority, yeah. Yeah, Evmos, maybe for the people that are not aware, is EVM blockchain, layer 1. And I could explain a lot of things about, I guess, the like compatibility with like the Ethereum client and everything. But the main things to remember or to really understand about Evmos is that we're building the innovation to really connect applications on several blockchains to really foster interoperability between different protocols. So we've been initially we built Ethermint, which is the EVM library that has been forked over, I think, 290 times now. There's multiple chains actually using this library as their settlement layer and building entire DeFi ecosystems on it. There's, like things like Crypto.com, Kava, Kanto. There's a bunch more, and obviously also Evmos that are using this technology to build applications. And we really see like more, like basically for us, like the real big future and what we've been observing is that there's more and more technology coming out and the types of chains and architectures are really diversifying. However, the EVM for us has been really the primary and like the most used, I guess, application or layer for developers to build on top in a permissionless way. And so we really think that we want to simplify things, and I'll go into this topic a bit more, and I'll also run through a demo of how you can actually deploy these kind of contracts and build an application that's, you just need to deploy once on one chain, but then it's used from anywhere, from any other chain as well. And before we get into this, like one thing I want to start with is really this idea of, probably everybody here has been already working in crypto for a while, building maybe protocols, applications. You probably have some friends or family that you've been trying to like get in early into this new like system of values and decentralization. But like I find it still also personally incredibly hard to really convince people that, or like people that don't really have anything to do with crypto and blockchain, that this can be the new future, or already is. And so you might find yourself, encountering this situation that you already see, the danger coming, and you're trying to take all the people and all your friends with it, and trying to get them in on this ride early. And what I want you to imagine is that, you're actually working in crypto, but you don't really try to use too many technical words to really convince other people of the values of it. So we have things like wallets, networks, RPC, MEV, data availability sampling, like zero knowledge, all these things that are super interesting and obviously really important to discover like the next technological advancement. and make things easier, but when we're actually talking about it, it's really about keeping it simple. And so that's why I want to give a bit more like a simple introduction to this. And what this actually means, or actually, I mean, coming back to it, like, obviously, we're still working on all these topics, and they're incredibly important, but when you're, explaining your application, even in like Web 2 projects like Uber or Airbnb, you're not really concerned with the database that's, underlying when you're telling somebody about this product, right? And before, I started my journey in crypto also as a core protocol engineer, but before I was working in product in Web 2, and so now I'm working again in like more the product side, where I find this is really important for really adopting more users. So what I really want to simplify this to is that when you're building your applications, I want you to think about, there's a user that wants to do something, there's some kind of intent, it's pretty simple, right? And they get something back, that's the result, that's how you want to actually pitch your product. And there's something in between that's happening. And for the developer community, it's obviously important, but that's the simplicity I want to get to, and that's how I think we'll also be able to convince people to use our products. They're just more concerned about, like what they can get out of it, right? Maybe it's an investment, maybe it's hedging their risk. They're maybe financial, most of them probably financially interested, but maybe also they just want to have fun. Or they actually connect to the values that the developer, the community is building, and that's why they're using your product. So if you think about building a new application, try to really think big picture first and abstract it in this kind of way. And obviously this word intent has already been used a lot now for more this kind of like the user is requesting or making some kind of a demand, and then there's maybe different like actors trying to fulfill this demand, but it also becomes quite technical. But that's kind of the way that we think about it on a high level. So one of the observations we make right now is like, why are there so many chains, right? So if you look at the most like, I guess, like the blue chip applications out there, like Aave for lending or Curve as a DEX, like what you'll find is obviously this big drop down of a bunch of different chains. And I want to really challenge this, and at Altiplanic and Evmos, we really want to challenge this and say, well, why from an end user perspective is there this drop down really necessary, right? On the background, you obviously know like there's these teams deploying this application on multiple chains with individual liquidity, which might also be fragmented, and as well as like different maybe wallets or onboarding experiences. But that can be very overwhelming. And from the way that we use applications, at least nowadays, as an everyday user, you're not really able to make a decision here, okay, which is the best chain to use. And you probably shouldn't be. It's really not really the end goal, as we find. And so there's two major problems that we observe at the moment that I want to get more into. So the first one that we see is that onboarding users is incredibly hard, right? Like if obviously like you can explain to somebody or go through some docs to maybe set up your wallet on Ethereum or any other chain, but if you have to think of like having to do this for 8 or 9 different chains to really also manage your wallets, it can be quite overwhelming. So why do we actually need this? And so I think this is a challenge that we really need to overcome and think of it in a way that you only want to onboard a user once to like having an account, the notion of an account or a wallet or an address. Even like using these kind of terms is actually super important, right? So what we did, for example, as a first step, and there's obviously many more, not just on Evmos, but what we did is build such a like an onboarding guide, which we called Copilot. And play this little video here. Basically, it just is like a widget to like help the user onboard to MetaMask or Kepler, and then create their wallet. And there's some like fun things here built in there, but it also lets you onboard like on-ramp And the idea is really like trying to abstract all the, the crypto wording away. So if you even like look at like simple things like in the UX, if you look at the connect button, usually like many applications have connect wallet on it, but having just connect, sign in or things like this make a big difference. And so the idea really for like onboarding users is like the goal should be you should be only onboarding them once to have some kind of idea of a wallet, of some kind of account that they hold their assets in and can interact with or identify themselves. Obviously, for security reasons, you might simply, similarly as you have it with your normal bank accounts, you might have several ones because of, you want to diversify your risk, but we really want to get to that parity. The second big problem that we see with this, like why are there so many chains, is really this idea of mercenary, like multi-chain capital, where we have really more like, I guess, successful applications, like widely used applications popping up and like originally starting in Ethereum, like DeFi summer. And they, obviously they're also opportunistic and try to deploy to as many chains as possible, maybe even getting paid for it, but like basically you're deploying the same code on several ecosystems. And so what we here see is, this, or what we actually want to see and what we're building towards is shifting this idea of a multi-chain Dapp strategy to a cross-chain Dapp strategy. So if we take the example, for instance, of Aave, like we saw before, you could have the Aave protocol for lending be deployed on several chains at the same time. This causes, you have to also maintain the different upgrades or kind of take part in maybe like understanding what's happening, and you have different liquidity and liquidity pools everywhere, but it really is more like a redundancy, and it creates this idea of like it's not really scalable. That's the point. And so what we actually are building towards with like the EVM on Evmos is this idea that you'd only have to deploy it once, either on Evmos or another EVM chain, but then you can really access this application cross-chain from other networks, from like other accounts. And so you'd only have to really maintain like one interface, one API to interact with this application, and but still be able to, like access different chains. So those are kind of like the two, I guess, major problems that we see. And if we solve them, what we actually see in the future is, two specific things. And I wanted to give some examples, which we call omni liquidity and I guess omni NFT. So if we run through like stories, like, yeah, you can borrow something, like borrow assets without really knowing from where. You just like trust the protocol based on, other users and the verification of the contracts. And you could say something, well, I want to use Aave to borrow some Atom with ETH. But the important part in this story here is that you don't really say where it's from, right? The chain is not really part of this sentence. And so that's how we kind of are thinking about, building new applications. And the same thing with NFTs. Like one thing you could say, I want to buy a BadKit NFT. If you're familiar with these ones, they're pretty popular in Cosmos at the moment. With ETH on OpenSea application and use it in my game or whatever. But again, this really doesn't have this notion of a chain specifically. And then, so that's how I want, actually us as developers to really think about what we're building. Okay, and so how does this actually work? How are we, like what are we really relying on to really build these cross-chain applications? And I think the big benefit of using, the Evmos technology is really that we are using IBC, which is the interblockchain communication protocol, and it's basically just a standard. View it as a bridge to really transfer data safely between chains, and it's been in production in like plus 60 chains since the last 2 years, and never really. I mean, obviously there's like smaller fixes that have to be made and so on, but it's really been proven to be a very secure protocol. And even with hacks like, not hacks, but like, I guess, downfalls of like protocols like Terra or whatever, there's like this protocol really like withstood the test of like some protocols, I guess, dying, but like still being able to run sovereign blockchains and yeah, be secured. And so the way that this works is that, I mean, if you have more questions, if you're not familiar with it, happy to like dive into it deeply, but it basically is just a way of like defining like a packet data standard, and you can send it between chains, and as long as your chain adheres to the standard and you're setting up like lines on each chain, you can like safely transport data. So this is just I think an older screenshot. There's, like I said, more than 60 chains now. They call them zones here at the moment. But this is just an example of like how many application-specific blockchains are already using IBC and are connected and transferring data. So there's a lot of potential of this omni-liquidity, this access to a lot of liquidity, instead of really thinking that it only has to be located on one chain. And so there's like, I think, 3 topics for interoperability that I want to highlight. So the first one is that if you'd start, your own chain, for example, using our EVM, then you still have like this problem that you actually need to bootstrap the building blocks in DeFi, right? You have to have a DEX, you have to have some kind of notion of a stable or secured asset, have lending, things like this, that will really be able to, or allow users to actually make good financial, or like a healthy financial transaction. And that causes a lot of effort in the beginning. But if you have access, or if you have an interoperable chain, then you don't really need to bootstrap this on your own chain, but you can make use of these applications that are already deployed somewhere else. Same with liquidity. If we're all talking about TVL and seeing how like developers move to the ecosystems that have the biggest liquidity, like the idea is really that if you are adding your chain or your application in this world where interoperability is a given, then you have access to all this liquidity by default, and it's super important. And the third one, I mean, I already mentioned this quite a lot, is really the UX that can be enabled for end users. All right. And the thing that we're building at the moment is this thing called dynamic IBC. So I was talking about interoperability between chains, and I guess users on different like IBC-enabled chains. But what we actually want to get to is really that smart contracts on different chains can talk to each other and are interoperable with each other. And this is called dynamic IBC because it's really permissionless, and you don't need like core protocol or chain upgrades to be able to add new packet types, but rather say, hey, I want to deploy my smart contract and my protocol on one chain, and I'm able to define my custom like packet type, like packet data, and be able to send that to another chain. And so that's why we call it dynamic, because it really is more flexible, or like custom and permissionless. It's not really reliant on the core protocol updates. All right, so I want to get into like 2 use cases, and the second one also will do a demo of what this means. So I think I moved one of my slides, actually. I'll get back to this one afterwards. This one is actually the next one. So what we recently did is upgrade on the Evmos chain, which really was the big first milestone for like making this deploy once use everywhere narrative a reality. And what this upgrade entailed is this thing called EVM extensions. And basically, this really enables like a shift of thinking about like having a TVL in one chain, but rather saying, hey, you have access to a bunch of other chains. And the way to think about EVM extensions is that without them, smart contracts on the EVM are really contained only to the EVM itself, right? You can talk to other smart contracts, but you cannot really break out of it or don't really have access to the core protocol level. And with EVM extensions, we actually provide an interface in Solidity that smart contract developers can use to really access core protocol functionality like staking, voting, anything really that's also custom on the core protocol, and especially IBC, which would allow smart contract developers to transfer data to other chains and vice versa. So with staking, you can build things like staking derivatives, staking managers, things like that. With voting, you could build sub-DAOs, anything really on a very permissionless level. And IBC, like I said, can be used for these cross-chain applications, or we call them IBC dApps. So now I'm getting back to this one. So the first one that we really want to showcase is this, I guess, outpost with Stride. Are you guys familiar with the Stride chain? Yeah. Okay. So Stride is basically its own chain that provides liquid staking for native Cosmos tokens. So Evmos is one of them, and right now what you can actually do is like it takes a few steps. As a user, you would send your Evmos token to the Stride chain. Then you can liquid stake it there to receive a liquid staked asset, like staked Evmos, and then send it back either to Evmos or another chain to use it in a DeFi protocol. And for that, you'd have to be really connected to the Evmos chain first. Then once you have that asset on the Stride chain, you have to also create your wallet on the Stride chain and send it back. And you like keep connecting and switching between the networks. And what our EVM extensions actually allow is that you can deploy an outpost contract, which is just a smart contract that users can interact with all the wallets that are supported, such as MetaMask, and then do one transaction to do this whole flow of like sending the token over to the Stride chain, liquid staking it, and sending it back. And so a user just has to say, my intent is I want to liquid stake, I sign this one transaction, and voila, I'm receiving a staked asset. I'm not really even aware that like this is happening on a different blockchain, right? I only need to be signed into the Evmos network. And so this is really cool from a user perspective, but even better or even more innovative, I guess the big difference here is that this service, like the liquid staking with one transaction, is also available from the smart contract level. So you could build an application that uses this almost like an API and then uses the results to do some other further action, right? Taking the liquid staked asset and deploying it in a DEX or like a liquidity pool or whatever. So this is really interesting, and from a I guess from a user's perspective, like this is the normal Stride interface, and the big difference is you're not really connected to the Stride chain, but to the Evmos network, right? And you could also build, and that's what we're also going to have quite soon, like a widget on our application, where you can, as soon as you're onboarded to to Evmos, you can liquid stake your tokens with one transaction. All right. I have Vlad's post here, who's also sitting in the audience and is giggling at me, so that's kind of hilarious. But yeah, the second thing I want to show you is an outpost, and we call these outposts just maybe to explain, like because like in the Stride example, we don't have to redeploy the Stride protocol, right, on Evmos. It's just like that one protocol is laying there, and it's not Evmos only. There can be other chains that are using this service, right? And so we say we have an outpost of Evmos on the Stride, an outpost of Stride on the Evmos zone. And so same thing I want to go into is osmosis outpost. So what we want to go through also in the code, and I hope the Wi-Fi will be good, but we're going to try to make a transaction on mainnet where we are sending the Evmos token to the osmosis chain, performing a swap, and then this from Evmos to Osmo, and then the Osmo will be sent back to the Evmos chain in one transaction. So basically, you're just using the osmosis DEX from the Evmos chain. And that is accessible, like I said, not just from users, but also from a smart contract level. And this was also introduced in our latest upgrade. Yeah, so we're gonna try to attempt this on mainnet. So let me zoom out here. I've tried this before today already, so a backup, we'll have it here. But first of all, any questions for what I'm trying to do here? Is it clear? Okay. All right. So we're just going to look into kind of the contract that's deployed and what kind of interaction you can do there. And like I said, the goal is do one transaction to perform the swap. If I look into my assets here right now of the account that I've connected, I have like around 3 Evmos and or a bit more than 1 Osmo, and we're going to attempt to like send 2, sign a transaction that swaps 2 of the Evmos to the Osmo token. And so what we have here is just this outpost contract. And there's one, I've already actually loaded it into a remix, right? You can we deployed this before at a given address, and you can load the interface into remix, so you can just interact with the contract. And we have this one function called osmosis swap. And this basically does 2 things. One is you approve the transfer, and then the second one is you're creating an IBC transfer that is going to initiate this whole cross-chain swap. The approval is basically just approving the contract to kind of spend the amount that you want to send in general. So there's basically this approval that is happening and is also imported from the interface of the EVM extension. So if I go to this ICS20 Sol contract, for those who don't know, ICS20 is just the packet type for a normal IBC transfer. And what we basically built on the core protocol is this. This is basically the interface for the EVM extension for the IBC transfer. And so this is like a given address at which anybody can really perform IBC transfers from a smart contract, and then it'll give you the interface such as transfer and the actual and the returns, and the actual logic is deployed on the core protocol. And so first, basically, we're just running through an approval of the amount that we actually want to transfer, and then we compose the actual transfer transaction or message, I guess. And the way that this works is that the normal ICS20 packet just has the denomination that you want to send, the amount, as well as this additional thing called a memo field. And this memo field can be, I guess, misused a little bit to really include all the information that would be required to do this cross-chain transfer. So on the osmosis side, what they've actually provided is this almost like a middleware that understands or parses this memo once the IBC transfer arrives, performs the swap and sends it back. And so this memo is then also included in this ICS20 transfer. And all of this is basically one function that you can call, which is the osmosis swap. So Hope it's big enough. So if you are interested in actually doing this yourself, then you can also follow this tweet, right? So I'm gonna shout you out, Vlad, because all of this information is really explained here with like the extensions repo. This also includes the Outpost contract that we just looked into, as well as the dependencies or the imports here of like the EVM extension interfaces, which are also in this repo. Just note that I think by default it is connected to testnet, so you might have to actually change the addresses if you're working on mainnet. But all of this is also described in the thread. So let's do it. Let's try to actually perform this cross-chain swap. So just confirming that I'm using the right things here. So basically the inputs that this function requires is the amount, right? The base denomination that you want to send, and the one that you want to receive from the swap, as well as the receiver account. So we want to get the Osmo back at a specific given address, right? And so we have like two Evmos here. You have obviously like the Evmos just to provide the right denomination, and we want to get Osmo back. And this address is, I believe, my yeah, like we basically have two representations. If you're not familiar with this, but this is the classic hex address that you know from Ethereum, and this one is more from a Cosmos ecosystem, which is BEC32. But yeah, I believe you can also provide both. Yeah. So yeah, we want to perform this transfer. Let me just collapse this last one and do a cross-chain swap. So we're going to have the like MetaMask connected here with injected provider. So make sure to actually do that before. Pay the gas fees. And then it's going to actually approve, right? And it's going to send the IBC transfer. And okay, the Wi-Fi worked. I'm happy about this. So if we look into this a bit more in detail, maybe make it a bit bigger, it gives me, the address that I interacted from and the contract address that I interacted with. And most importantly, it gives me the logs, which are the transfer authorization for the IBC transfer, as well as the IBC transfer itself, right? I can also look into this on eScan, which is our block explorer. So if I'd go to this latest contract interaction, I can view it on the block explorer, where you have a bit more nicer interface, I guess, also of the logs, and see exactly what's happening here. And this block explorer is cool because it also, actually lists the EVM extension that you're interacting with. So yeah, we hopefully have 2 Evmos less, so let's see, and some more Osmo received afterwards. Okay. So if you remember, it was at 1.2 something, right? So we actually did a cross-chain swap, which is pretty cool. And if for the more visual people, if we actually go to the Osmosis interface, which hopefully loads, we'll wait, we'll see. Usually, like I said, I think the important part is that this is, accessible for users, right? But even more important from the smart contract level. This is really what we're focusing on. So yeah, we just did a cross-chain swap on mainnet, which is amazing. And you could say like, hey, I want to actually, I don't know, swap 1,000 Evmos, get Osmo back, and then use the result to provide liquidity on a DEX on Evmos, for example, or on another chain, or even on Osmosis. So that's kind of the idea of like this osmosis outpost. Any questions? Okay. Did this one load? No. Let me check if I can show anything else here. I guess in the block explorer, if I refresh this, what we do see is this is the contract that we interacted with. So 2 minutes ago, right, we did this interaction. So it's all already here. And if I'd go to my wallet, I should also be able to see the incoming IBC transfer. So as soon as you actually swap on osmosis, you will actually, there's a second IBC transfer that's initiated to send back the Osmo token to the Evmos chain. And so you can also see that this actually is captured in the logs and also displayed here in the block explorer. All right. Cool. So jumping back into here. Yeah, if you wanted to try this at home, you can do this on mainnet or on testnet. There's both is possible. I like to do it on mainnet because there's a bit more of a rush happening, you know. So where does this all lead us or bring us to? I was talking about, yeah, you want to provide like applications to end users, right? And the one way that our team is really thinking about it is we want to provide, you know, an interface where users can do this in a really simple way, and where developers can also understand that, like, hey, this can be really easy, and I also want to build my application the same way, or use this like cross-chain connectivity or interoperability to, yeah, not have to bootstrap my DeFi, not have to worry about liquidity on my specific chain, things like this. And at the moment, this is our, you know, our normal like app.evmos.org interface, but what you'll see quite soon is that this will be also replaced with like basically like more widgets, more like call to action things where users can directly use these protocols, right? You just connect your wallet to this interface, and you can already like liquid stake. You can cross-chain swap on Evmos, on Osmosis. You can do all these things, and developers can also build like more, I guess, advanced strategies and offer them to users. So that's really our, I guess, our end goal, and that's what we're working on at the moment, and will be really exciting to see people use. Just zooming out, like, I guess when I give this workshop or this talk, I really try to not talk about Cosmos too much, because I feel the Ethereum world is really still like so much bigger, and for us, really we're really like a port of entry for this kind of world, and yeah, EVM developers exploring what other technology there is, right? And it doesn't really matter so much in the first place that there's, you know, that I guess our chain is also built on the Cosmos ecosystem. But the important part is really that we're like leveraging this technology to really have the ability to use IBC in a really like standardized way. But just still, like, there's actually, if you account for all the liquidity in TVL in the Cosmos ecosystem, it amounts to almost, I think this was at a time like $1 billion a month ago or something, $1 billion. And yeah, we are also seeing already more Ethereum, like layer 2 applications also trying to adapt IBC, and there's a lot of big interest there. So we really see that that's going to be like the future. So just remember, deploy once, use everywhere. And thank you for listening. And if you have any questions, happy to answer. Anybody? No worries. I'm also around. Happy to talk about anything. And yeah, enjoy your day. Thank you.
Hello, everyone. Welcome. Welcome to our workshop. I'm here to talk about Chainlink and especially about the cross-chain protocol. So this is our goal. And thank you so much for the Dappcon team for organizing this amazing event and to have me here. This is me. My name is Solange Gueiros. You can call me Sol. I am a developer advocate at Chainlink Labs, and I used to travel around the world to conferences to talk about Chainlink and to teach developers, and I really love to teach and to bring in new people to this Web3 ecosystem environment, and I really enjoy to teach. The last link is my website. I used to add my talks over there, so you can see other talks and workshops. And we are here. Let's go to this place first, before I talk anything. And here you can put like your name and where are you from? Like I'm Sol, from Brazil. And okay, let's add this here to help you. We are in this link now. And this is a collaborative pad. We can write together. We can delete everything, so be careful. But this is the best place to work together. And I used to say that if you know how to copy and paste, you can do my workshop. Because I will copy and paste all the code for you here, all the instructions, and you can do the same in your own computer. So welcome, Christopher. And let's wait a bit more for the others. And like I said before, I will talk about the CCAP. This is the cross-chain protocol communication by Chainlink. And when we talk about this, I used to do 3 or 4 approaches related to how can we do this. Like you can transfer tokens, we can transfer messages, and when we talk about messages, we can transfer commands and call functions. And this is our goal today, because my goal is to mint an NFT in one chain, and this NFT will appear in another chain. And I'm doing this only using Remix, so we have like a hard hat starter kit as well, but I'd like to do in the easy way, so we are not installing nothing on our computer. It's only using Remix, and we need to have some tokens. I think the hardest part is to get the tokens. My goal is starting on Avalanche Fuji and finishing on Ethereum Sepolia. So I will send commands on Fuji, a transaction on Fuji, and this is send a transaction to Ethereum Sepolia, and our NFT will appear on Sepolia. Is this? Wow, we have Luke from IT. Where are you, Luke? Oh, nice one, Luke. And a lot of people from Germany as well, and George from Spain. Oh, amazing. Welcome to all of you. And this is, let's come back to my presentation a bit more. And to understand a bit of the concepts, how can we update NFTs with blockchain oracles? First of all, remember that NFTs representing something can be a punk, a ticket, a real estate, apartment, or badges, or trading cards. And but even today, the most part of the NFTs are static, and the goal and the feature of the NFTs are to be dynamic. In this case, I have an NFT from LaMelo, the basketball player, that is updating using his scores. And when we talk about updating NFTs, you can define your own rules to do this. Can be scores, career highlights, weather, experience, whatever. And my goal, I'm finishing a new workshop, and the idea is like to have the same NFT in two chains, and you can, for example, using the metadata to see where is active, where is not active, for example. For today, I'm only meeting the NFT in another chain, but the goal is to create a NFT that can live in different chains and be dynamic in this way as well. When we talk about oracles to update an NFT, it's important to know what's an oracle. An oracle is any device or external resource that you can use in your own smart contract, and you can talk about like temperature, weather, sports information, financial information. I have a lot. Even the information from my watch, I can use this as well. And this is Chainlink. When we talk about oracles, we are all important. Chainlink is not a blockchain. Chainlink, it's a set of services that are deployed in different blockchains. Like this, we have a network of nodes. We used to say a DON, Decentralized Oracle Network, for different services. And we can have these services for data feeds. This is the most popular. But also, we have services to automate smart contract execution, to generate random numbers, to call external APIs that you can write code on JavaScript and use this information inside the smart contract. And this is some examples of dynamic NFTs that I did before in workshops, like to grow a flower, to have these characters that can can do something different. Today we are using these characters as well. This is our NFTs. And this is another that I did before. It's like SVG price feed. Imagine that if the price from one time to another is growing up, I'm happy, or if it's going down, I'm sad. And we have different background colors. And all of this is another dynamic NFT that I code everything inside the smart contract. So this is interesting. How can you update this? And this is our goal today, how to mint an NFT in one chain from another chain. And we are using the CCAP, Interoperability Protocol. And before talk about CCAP, let's start with the requirements. Because like I said before, this is the most difficult part. And I have here my requirements, and I will copy and paste here to you to be together. And we must have this. First of all, I told you that we are starting on Avalanche Fuji. So we need to add Fuji to MetaMask. If you go to chainlist.org, connect your wallet, and you can add it. I can't because I probably already have it. Yes, Avalanche Fuji is here. Okay. And the next step, you must have tokens on Avalanche Fuji. This is not good now. Probably we can go directly to the Chainlink faucet. And this is the same, you are connecting your wallet. And then here you can get the link token and the Fuji token. Here, I can get 20 link tokens and 0.5 Avalanche Fuji tokens. I need to do a login using Twitter. Okay, if you have any problems, I can send to you later, okay? Another point, when I'm doing a cross-chain transaction, imagine that I must pay fees in the destination chain. How can I pay this? I'm paying this in the Source blockchain. And I can pay using the native token. For example, if I am here in Fuji, I can pay using Fuji. I can also pay using Link. And in the future, you can pay using other tokens as well. For us, like to get Fuji is not so easy in this moment. So I'm using Link to pay the fees because it's easy to get the Link tokens now in testnet. And this is our goal. You must have Link token and AVAX Fuji. Got this. The other part, I don't know what is the chain safe you want to. Oh. Okay. And the link. And also you must have some Itsepolia. This is most common, so I hope you have it, but if you don't have it, do you need tokens? If you need, you must tell me your name, which token, and address. And probably I will try to send you in a minute, okay? Let's come back to our presentation, and you are getting your tokens now. So come back here. When I talk about cross-chain interoperability protocol, what can I do? I can transfer tokens. This is the basic, like a bridge, but we have a mechanism with a bit more security. You can send any message. I used to send like a hello world, hello Berlin message from one chain to another. But when I'm sending message, what about a message that is a command that is calling a function in the other chain? And we are using this today. And in this point, when I can send commands and functions to the other chain, I can program a token transfer, for example. And like this can unlock the feature of an internet of blockchains, because you don't have limits in this way to interact between contracts. And this is a bit of the cross-chain stack, like wallets, applications, where can you use it. And also, one important point that I need to tell you is related to the workflow. And here, we have a risk management network. So we have two different networks of nodes. One network is really monitoring one chain, getting the transactions in the router and sending to another chain. And there are another set of nodes that are really monitoring this in a security perspective, okay? So we have both. In some moments, I come back here to talk about use cases, but between this, I need to wait some minutes to my transaction be confirmed, so we can talk about this later. Let's go to the practical part again. So Felix, in a few minutes, I will send token for you, okay? First of all, we are starting on the destination chain. And this will be Sepolia. So in Sepolia, I will do 2 points now. First, I will create an NFT collection, an NFT smart contract, and then I will create the destination smart contract, okay? So, like I said before, I have like my copy here to tell you. We are creating the Chainlink NFT. Oh, wow, we are on Remix. Okay, don't forget that we are on Remix now. Let's go to Remix. So this I will do in MetaMask. And now I'm going to Remix. And first of all, in Remix, remember to go to the icon 5, environment, and injected provider. Let's do this. Remix 1, 2, 3, 4, 5. Environment, change this to injected provider, MetaMask, to be sure that your remix is connected with your wallet and approve this. I also used to go to Solidity compiler and enable the auto-compile. It's faster to you to work in this way. Icon 4. Let's enable the auto-compile. Now we are going to icon 2, File Explorer, and create our file. So we are creating the Chainlink NFT.sol. And here we are. What I have here, you can copy the code between the begin and the end. Let's create it. Let's see if I have it here. Yes, I have it. So I will use mine now. And probably I will change the name of NFT. This is the Chainlink Dappcon. So let's update this for you as well. Line, where is the constructor? Constructor. Oh, the last time that I did this was in Argentina. So we are on Dappcon now. So is this is our NFT. And yes, you must trust in my code now. But probably I copied something that more than I needed. Let's go from here until here. And let's deploy the NFT. This is only the NFT. And if you are with me, please add here your name and your NFT address. Let's get mine. I think I am in the wrong network. Let's see. Yes, I told you to go to Sepolia, but I won't. I didn't. Let's go to Sepolia. And now I can deploy. And so this is the wrong. Yes, let's get this. And where is the people that need Felix? Let's send to you. I think this is good. And the mouth. And the Mohammed. And to be sure, how was to create my contract, how much I spent. Oh, it's good. So with this, you can create your contract. Now I have my Chainlink NFT. Oh, Jordi, congratulations that you are doing with me. And this is, so we have the NFT in the destination chain. Now, when we send the mint command to the destination chain, we must have a contract to receive this command and to mint the NFT. So this will be our destination minter. Before that, if you'd like to see your NFT, maybe we can see before. If I go to OpenSea, this is the Chainlink Dappcon. I already minted one NFT in my collection during the deploy. And to understand better what's my NFT, I'm only using OpenZeppelin, the basic, to create an NFT. I have these 4 images, 4 characters that I showed you before. In the constructor, I define the name of our collection, and I mint the first NFT. And like I have 4 NFTs, and I'm alternating the characters one by one. This is the next character. You'll be like 1, 2, 3, 0, 1, 2, 3, 0. Okay. And this only this. I have here the safe mint, the mint function, and it's simple. Okay. And this is my NFT. This is my collection. Next step, let's create the destination minter. This is a contract that will receive the mint command. Okay. Let's get this for you. And the same, begin, end, and here is the code. And let's see if I have this done here, destination minter, I have it. I will explain what I have here. So here I'm using the Chainlink CCAP. I'm importing the CCAP receiver. This is importing the structures to the router because the process is we have a router in the Cersei blockchain that receives our transaction. We have another router in the destination blockchain that is receiving the transaction from the Cersei blockchain and following to our contract. So we must have the CCAP receiver. Also, we have the client library with all the structures that we need. And I have the NFT. So here, when we have the router, we must, in each chain, the router has an address. How can I say this? How can I discover this? Because I locked this in my contract. But when we need to get the routers, you go to the supported networks. And for example, here is Sepolia, here is the router. Let's add the support networks for you if you need it. Okay, oh, here. And here we are. In the constructor, I'm initializing the NFT with the address of the NFT collection that I just created. And I must have a function with this name, underscore CCAP receive, because the router is looking for this function in my contract. When he found this function, he's sending the message to my contract. And what can be the message? In my case, the message is a comment. So I'm using the message with the address of my NFT. I'm calling the message, the information. It means that I'm using the mint function here. I will send the mint function from the other chain. Is this? And I create a test mint only to be sure that this is okay. I think I didn't create yet, so let's deploy the destination minter. I need to get the address of my NFT, add here in the parameter of the destination minter, and deploy. Confirm. And if you are with me, could you add here your name and destination minter address? Maybe I can try to interact with you later. Is this? This is mine. At least mine I will add for you, and you can use mine as well if you like it. So this is done. The destination part is good. Let's go to the Cersei part now. Cersei blockchain, UB Avalanche Fuji. So you must select this on MetaMask. Let's go. And this is the Cersei minter. Okay, I will add this for you. So now you must create the sourceminter.sol. Let's put this here. Here we are. Remember that you must go to Avalanche now. I am on Avalanche. Okay. Sourceminter, I have it here. And here you can see that also I'm importing in the source blockchain, the source contract. I'm importing an interface to the router, is this. The client of the CCIP as well. And because I'm paying using link, I must have the link token interface. I'm managing some parts here, like to see if I have enough link to pay the transaction, if I, at the end, would like to withdraw the tokens that I added, in this case, the link token. So I'm managing this. I will define the source router, the link token. Because I'm sending to another chain, I must know the code of the destination chain. I can get all of this here in the documentation. The chain selector is here, for example. And is this the destination minter? It's my contract that I already deployed on Sepolia. In the constructor, I created this in a way that only the owner can send this message, but you can do to any person do this. Here is the router in Fuji. For example, let's see here. If I go to Fuji, here is the router address that I'm using. It's here. And the link token as well. I got in the same place, link token. And the destination chain selector, it's Sepolia. So I'm minting on Sepolia. I'm creating a structure that is a message, EVM to any chain message. I must say what is the receiver, what's the address of the receiver in the other chain. What's my message? In this case, my message is the command, the function mint to the address. If I'm sending token, here I can define the token amounts. And in my case, I'm increasing the gas limit to be sure that I don't have problems in the destination chain. Here you can see that, okay, I am on Fuji now. I must know what is the fees in Sepolia? And this is like the hardest part. Sometimes I already got errors live because I send the transaction and the fee increased in that moment. What I sent, it was not enough. In this case, you can manually execute the transaction in the blockchain, destination blockchain. I can say you later. But you must be careful because now we can get fees, but this can change during the process, okay? And this is, we are sending a message to the destination chain, and the message is the mint command. Here I have the link balance, and to withdraw the link, it's only the owner that can get the link back, is this. Let's deploy this now. I must use the destination minter address here. Copy. Confirm. And could you add your name and source minter address? You are not with me. I'm sad. If you are doing. So let's get mine. Source minter, here we are. This is my address. Okay, next step. Hey, Mount, thank you, you are with me. And now I must fund the source minter. Remember that we are using the link token. So I must send the link to my contract. I can do this on MetaMask. I will send 10 links to my contract. Let's go to MetaMask. If you don't have the link token appear here, let's solve this. Maybe you don't have it. Hey, George is doing as well. How can I add the link token? Go. Link token contracts. It's a bit slow now. And I am on Fuji. You have the Add to Wallet button here, okay? If you need it. Let's see if I have it. And get my address again. Here I have it. Send. 10 links. Oh, congrats, George and Felix, that are doing with me. And here we are. Let's see if I have the tokens here now. Yes. So everything is done. I can mint on Sepolia now. And the important part now is to have your transaction ID. Let's do it. Remix source minter, mint on Sepolia. Confirm. And I will get my transaction ID. Copy transaction ID. And I will use my transaction ID in the CCIP Explorer. Let's search my transaction ID here. And you can see that the search was finalized. But when we talk about blockchains, we must have the finality status in the transaction. It means that we must wait more blocks to be sure that cannot have a reorg in the chain anymore, and to be sure that your transaction cannot be reverted. Because of this, we used to wait more blocks, more time. And this is the case now. We must wait some minutes to do this. And I'm used to start on Fuji because from Fuji to Sepolia, I used to wait like 4 minutes. But if I start on Sepolia to Fuji, it's 20 minutes. So exactly because the time block is different. In this case, we are waiting. It's committed now. You just saw that change the status. I still must wait. But when I'm waiting, while I'm waiting, let's talk a bit more. Use cases. Some ideas to you related to CCIP. Cross-chain collateral. Imagine that you can have collateral in one chain and do using lend, borrow, whatever in another chain. And you are locking one chain using another chain. Another point, imagine that sometimes it's so expensive to do computation, simply computation. We are about to do this computation in a low-cost chain and only bring the result to your main contract in another chain. You can also have yield optimization. You can have some profit between chains. And thinking about this, you can have different kind of applications, like I'm using NFTs, and you can have whatever you like. Imagine including a DAO that must vote. And a lot of times I saw DAOs deploying the structure in another cheaper blockchain. They started on Ethereum, and then it was so expensive to vote something on Ethereum. And let's do it in Gnosis, for example. Imagine that you can do this using a cross-chain application. And, oh, I have one more that I'd like to show you. This is the basic architecture and workflow that we are doing. We are the user. We deployed the sender contract. And here we define what is the message and where it's going, destination blockchain. Here we have the router that's receiving this. And outside we have the DON, the Decentralized Oracle Network, that's monitoring this and send the transaction to the router in the destination blockchain. And I am in the destination blockchain, so I don't have the destination chain anymore, but I have the message to send it to my receiver contract. In our case, I must have the CCAP receive function, like I said before, the underscore CCAP receive. But if I'm sending tokens, for example, I can send it directly to my wallet, and I don't need to have this part. And this is a CCAP message can be only arbitrary messaging, or a command, or a token transfer. This is a bit complex structure, so when we're talking especially about tokens, we used to have some mechanism in the token part. If you are the owner or the manager of the token, you can decide, for example, that you'd like to burn the token on chain and mint in another chain. But when we are not, Chainlink is managing some tokens. We have some test tokens now, and we can lock the token in the first chain, and in the second chain unlock or mint in the second chain. So you have the main token and almost a wrapped from that token in another chain. And you can manage this as well. And so important that, like I said before, we have another network of nodes that is monitoring all transactions to be sure that we don't have hacks, how we have a lot this year in bridges. This can be good for you before I come back. Like I said before, I have this in a hard hat package as well. So if you like to build more complex stuff, it's better to use hard hat than remix. And this is another important QR code for you. This is the presentation. So all the links are here. And probably when I come back to the CCAP Explorer, my transaction is done. Let's see. One more minute. Okay. So let's see what's happened. Success. Yes. Well, it's success. So if I come back to my NFT collection, I should have 2 NFTs here now. Yes, I have 2. One was minted from Fuji. So do you have any question related to CCAP, or do you need tokens? Do you need help? Wait a minute. We have a mic because we have people online.
Hi. Can you elaborate on the risk management part?
Yes. There are another set of nodes that these nodes cannot commit transactions. They cannot see. They are monitoring this. So let's come back to my presentation because I have this in a detailed architecture and workflow. Here we are. When I have the router is sending tokens, something like that, the risk management network is writing in a smart contract. This is like another contract that's committing the transaction. So I can right here, and this contract is monitoring all the transactions here as well, using events to help this. In this way, before the transaction go from the source blockchain and be in the destination blockchain, this network is also monitoring the amount of blocks that we need to wait, and monitoring and be sure that the transaction will not be here before that. And also we have a structure that we are committing and saving the transactions in a smart contract that you can see where is this. So all of these are transactions on blockchain, and this is transparent, and you can see what's happened to be sure that we don't have, anyone cannot manipulate this. Okay? Also, if you need more information related to this, you can go to the resources, and not the resources anymore. You can go to the architecture and billing and concepts of this, okay? And let's see, Mount, what is your transaction? Let's see. What's happened with your, probably what I did wrong. No, I add his name together. Okay. Mount is done as well. Yes, so good. And to finalize, also next week, if you are from Berlin, we have another boot camp. Like it will be 2 days, Monday and Tuesday, 4 hours per day, where I will teach you how to use all the Chainlink services. So if you are around here, you are welcome. And are you starting from zero? In this bootcamp, I will create ERC20 tokens, NFTs, and a token shop, and automated contracts, and create a raffle. I really create a lot of things.
Is that available remotely as well?
Only in person. For the remote people, you can check our website as well, or even my website, I have more online. And these are my contacts again. Feel free to contact me, and I hope to see you around the conference. And thank you so much. Also, if you need to talk more, I have Joy over there, Joy. She's a community manager from Chainlink as well. She lives in Berlin, so feel free to talk with her as well, and we are here to help you. Thank you.
So the music stopped. That means that I'm going to take over. Welcome, everybody. Today we'll do a little workshop in a journey through building and testing and doing CI of smart contracts, but also testing of the Dapp UIs, like automated testing of the UI specifically. And we're going to do that using a piece of Tenderly technology called DevNets, and you'll see it all as we go along. This QR code that you're seeing on the screen, if you could scan it, it will give you a link to a Notion page, which has a walkthrough through the workshop itself. Let me know if that works or doesn't work for any reason. So I'll just wait a bit for that. Okay, works. And I suggest if you could open it on your laptop, because during the workshop you will need it. So let's get that set up. All good there? Okay, now I will do an unorthodox thing. I will ask you all to stand up and to approach. Sorry? Yes, everybody has to be like close. And while you're getting here, the agenda says 2 hours. I think we'll finish sooner, so that leaves us time for more questions or trying something together. But for now, if you could all approach here closer to me. As you know, the workshop is a little bit about building and testing and what happens to that in the world of Web3. So I would just like to see the movement in your experience and your thoughts and views on testing. And we're going to do it like that. I will say a statement, and whoever wants to say yes goes to this side. Whoever wants to say no goes to that side. Let's try this out. I came here on a horse today. Oh, where did you park it? Yeah? All right. I have written tests in the past.
Make us work out here.
Yeah. Get your bodies moving a bit. All right. I was made to write tests in the past. I do think it's a good idea to write tests. You're the one of the, I'd rather revert. Yeah? I've used or set up a CI in the past. Okay. All right, so today I'm hoping that everybody will be standing on this side of the room, because we will write some tests, we will see some tests fail, we'll set up some CI. So now that we know the feelings about testing, that's cool. One last thing. I'm familiar with Hardhat. Hardhat. All right? And I'm not familiar with React. Okay, hardhat people, no front-end people. All right. So the best way to go through this is actually to work with somebody in a pair. So if you want to, you can just randomly pair up and go through the workshop together. Maybe just the person closest to you. He doesn't count. He's a. This is Philip. He'll be helping out.
I'll join in.
All right. So I had fun. Hope you had fun as well. Let's see. Let's spend a little more time, and maybe you and your partner could discuss 2 questions: testing, yes, no, and why. And most importantly, what's your experience with testing in Web3? Or what would you like it to be if it's not that? So we have 5 minutes for this. Chat away. Of course, you will be sharing with the group afterwards, so no pressure.
It depends.
That's not an acceptable answer. Yeah, you can make a... You're speechless. You got 3 more minutes, so I can cut it shorter.
Do you guys prefer Hardhat or Foundry for tests? Foundry. Why? Speak.
Also, I mean, we can do all the operations, like all the cheat codes on the EVMs. We can set up like an algorithm with the amount as well. Makes things easier.
The life that you are convinced with, so you just language.
Context switching on like languages, OTS.
It's true, man. I haven't done much Foundry, that's why I've done this for a couple of years, so that's, in my mind, it's normal mode. Oh, you're right, it's 2 different languages for the same thing.
No, but even on this setup, I mean, Foundry, you can just set up your the EVM as you want, like some states, like one whole, you can set up like storage, something, another the balance.
I don't
It's
know.
much.
I don't know if other test this limitation, how you can test solidity below 0.5. Because it doesn't have support. I was part of still less. Yeah, for the whole ones. Most of the tests are which is pretty worse. Because you can see the compile.
Not yet.
Please.
Yet.
It's more about the front end interacting with smart contracts.
So
How do we test front ends? I mean, trial. I don't do front ends, to be honest.
Manually, I think.
I did still look at it, if it was nice.
And I think there's also security considerations there. I mean, I lost my
if I want to mute myself, how can I?
yeah, somebody
10 seconds left. Closing the discussion. And time. Let's share the impressions from the discussions you had. Who wants to share something with the group? No? You just joined? Okay. You guys?
Yeah.
Yeah.
We were just talking about how testing became easier, in our opinion, when Foundry came out, because
Mhm.
it's just it was easier than hard hat for us, at least.
Yeah. All right. And is there something from your experience that's missing in the Web3 testing?
What we just said.
Oh, no, not that. No?
I'm on the spot now.
Right, let's put the pressure down. You guys had a lively discussion. Maybe you want to share something?
About something that's missing?
Yeah, or anything that you concluded from talking about testing. Why and why not?
Well, about the why, we had some, I think it's a spectrum of yes, no. I mean, it's on there. Usually you should write them. I had a bit more the opinion that you should write them unless there's no risk and you're not working on it. You really just want to learn something optimized for speed. But most of the time you want to optimize for security as the code is handling money. And then we're discussing how to test. Like I learned testing with Truffle many years ago and stopped at hard hat. So Foundry is kind of new for me, so I learned a bit about the advantages of Foundry. But yeah, at the end of the day, testing's good.
Yeah.
Do it.
Test is good, do it. I think that's a solid conclusion there. Yeah, all right. So now let's get into the workshop. Let me tell you about what we're doing today. So today, you and your group, you get a little project. It's not mini-safe, I'm sorry. It's mini multisig. And essentially what it is, it's, well, a little UI that a team has made. Sorry, this is, for some reason, this is not mirroring.
Unplug it, plug it in again.
Yeah, maybe that might help. All right, it's not that. There we go. It's the PowerPoint. Okay, so essentially what this is, it's a UI that a imaginary team has built, and what it does, it's a little multisig. So I will connect it through MetaMask. Okay, now MetaMask is giving me a hard time. Okay, not wasting time on this, but you can imagine that it is a multisig similar to Safe. So you have options to create multisigs, to set owners, to add transactions, to approve them, execute them, everything that a multisig is. And your task is to take over the code base and to see where it's at, if there are any bugs, to fix it, and to go through some testing. And now let's just spend some time on the architecture overview. So we had one bit that is hardhat and two important contracts, multisig factory and multisig wallet. And the piece of infrastructure that's used here, for example, for testing and for staging the contracts is Tenderly DevNet. So that's a piece of infrastructure that we'll be using today. I'll explain that in a bit, but you can imagine that this command, run Tenderly DevNet new, actually takes mainnet, adjusts it a little bit, and gives you your own private testnet version of it. So imagine like you're having your Sepolia on demand, but it's just for you. You can manipulate the balances, the ERC20 tokens, and all that stuff. And you get an RPC link that you can use so you can actually test your code on the DevNet. So that's the first bit of infrastructure, the layer of smart contracts. How DevNets work, as I said, you can take an actual network such as mainnet, and these represent transactions, and you can write a little YAML file that is your declarative way of telling us, hey, I want to set up this, taking DevNet, taking the mainnet, but I want these accounts to have this much test teeth. I want these smart contracts to have some storage slots overridden by these values. So we just take the YAML, and when you want to spin it up, we do a couple of transactions that set it up. So in a way, it's a fixture of the network that you need for testing or doing some transaction scenarios and stuff like that. And the cool thing is, if you will spin up a DevNet and you get an RPC and you can use it, but then after a while you want to start over, so you can just spin up a new one and it sets it up in an identical way. So using a little bit of declarative stuff in there in the YAML. That's all about the architecture for now. There is the Next.js app that I failed to run, but we don't need it for the first segment of the workshop. So we can see that later. And for now, in the next, let's say, 15 to 20 minutes, you can go through sections 1, 2, and 3 of the workshop guide. First one is about the project setup and the dependencies you need, including cloning the repository that you as a team are taking over. The second is setting up a DevNet for yourself. And the third one is bringing DevNets to the hard hat. So go. If you have any issues in the meantime, you can call Philip or myself, and we'll just hop over and help you get through them.
Did I miss some URL?
So 15 minutes now. Who came a bit later? Here's the QR code with the Notion doc with the workshop guide. So scan it, open it on your laptop, because there will be lots of commands you should copy, actually. Let's do a little show of hands. Who managed to go through step 1? Okay. Step 2, the DevNet template. Okay. Who's stuck on npm install? We need something better. Yeah, I think this is the lengthiest part of this workshop because it's downloading so much. And somebody managed to finish the section 3 to bring it to Hardhead. Okay, take your time because we need to go through all of these.
Just waiting for it to install.
It's not working on Windows.
The CLI?
Like this is my question.
You got all the dependencies yet? Try my phone.
It's C1 104, it's still resolving packages. Still resolving packages. I don't know why it's so slow.
I'll check the file size of the node modules folder once it's done. You probably know. I'm doing my phone now.
Did you try to since you were trying to connect like to remote?
So while we're comfortably waiting for npm install to complete, I'll just go through the interface to show you around what's actually happening when you do the DevNet. So you've done the YAML configuration, and you've probably seen here that we have some wallets with some private keys exposed. And don't worry, it's just stupid wallets we use for end-to-end tests, so not used for anything else. And they have some balances overridden. So we use that one to configure the DevNet so end-to-end tests could actually work. And another peculiar thing here is that we've overridden the chain ID. So we did take mainnet, but we didn't keep the chain ID 1. Why? Because we want to prevent replay attacks. Even though these transactions will come from these completely irrelevant wallets, it's a good practice to just prevent this from ever happening. And when you get to the step where you actually bring Hardhead to bring DevNet to the Hardhead, you will run a command that will give you, well, one of these, which we call runs. So we take the template and we spin up a new DevNet. And you can see a bunch of things here. Let me just zoom in because the resolution is off. So you can see all the balance overrides that you specified. You can see the contract creation over here. You can go into classical, more of a block explorer kind of thing where you can see the transactions. well, nothing interesting here at this point, but will be later. And you can see JSON RPC calls. So if something fails in there, those calls should be visible. So those are all the calls that are sent by wherever, whoever uses the RPC. So you can actually see that and analyze as well. So just wanted to go through this a bit, and TV says enough. So keep going, and let's say in a couple of minutes we switch to the next stages of the workshop.
Is that interface UI only, or is there CLI that can have the same information, the RPC calls and stuff?
Yeah, so the question was just for the stream, if the interface is the UI only or there's a CLI. Yes, there is the CLI that you just installed. It's got a command that spins up a new DevNet. So you would define a template in the UI, and then you would use a CI to say, hey, tenderly spin up a new DevNet from this template. And this is exactly what that command hardhat DevNet new, or whatever it was, does. NPM install done?
Yeah. 750 megabytes.
Sorry?
Almost a gigabyte for me.
Yeah.
750. Both node modules for combined.
How about
Mhm.
On the login.
Yeah.
Tenderly logins, so they
Fine,
might
it's
try
not-
also email.
the actual download.
I tried also to install it
Stuck. If you're too stuck, raise your hand. Nobody's too stuck. That's good. Okay, so let's just wrap it up. The first part was very painful because we had a lot of configuration to do. There was prettier issues and stuff like that. But by now, hopefully you're. Let me just get this out of the way. Yeah, but by now you should probably have this multi-sig factory contract deployed on your DevNet, and we can take the workshop further. So one thing that I would like to sort of look into now is the way that, that we can actually use the CLI to deploy a new DevNet and also to deploy new contracts. So in this step 3, you had this command that runs this npm script, tenderly devnet new, and now you see it, now you don't. On this project mini multisig, using this template mini multisig tests, using this chain ID for it. So when I go to my hardhat, this is the lower window down here. If I just run this command, what happens there is that, and now let me go into the VS Code. Here's the hardhat. So I'm getting the configuration of the DevNet's RPC. I'm also getting the exact chain ID because hardhat has to know the exact chain ID of the network it's connecting to, otherwise it doesn't work. So if you don't have this number here or in the DevNet template, then you have to do the whole thing and reconfigure it again. And the second script that you have ran by now is this. Hardhat scripts deploy network to the network tenderly. So if I go back here and run it, again, you get the contract in there. Now, what this script does is, besides deploying it, also verifying the contract on tenderly so you can actually have debugging and all the cool stuff that you need. And now for the next step, this is why we waited for so long for npm install. You will actually run an end-to-end test. So let me just kill this thing over here. So I'm switching over to the front-end folder, and whoops. And I'm just running npm run test, and it's starting, so you can do this command alongside with me because hopefully you're done with the first 3. And what's happening is that we're running an end-to-end test that's written relying on synthetics wrapper around Cypress and Cypress and Playwright. So what it does, it takes the Chromium browser, the longest awaited install that you had, adds MetaMask, and then you can actually write tests that interact with the wallet. So you can test every single step in the flow of the UI using an actual wallet and a little network that's behind it. So as this thing runs, well, this is somebody proposing a transaction, and then the transaction shows up, and then that person approves it, and then there's a switch in the address. So now you'll see one green box, and here's another one, and then there's somebody who will do something. Come on. Something should happen now, but it's not really happening. Yeah, anyhow, you saw how this can actually go through the steps of executing an end-to-end test and actually messing with the UI. And the cool thing about it is when you go back to the browser, so this is the latest run, all of these transactions that we did end up here, actually. So these are the 3 transactions that successfully happened. So the thing that the UI froze a bit here means that there is a bug, that the team who did this, and I'm the team, left an error in there for you to find and fix. And there's also one little issue here. If you notice, oh, the tests have failed, that's cool. If you notice, you may or may not have your contract verified here. So this call multisig factory create, that creates a new contract. And these three are the calls to the very multisig. Now what happened, the verification, the very, very oldest problem didn't succeed. So what you can do is you can go in here into this transaction and you can go view details. And yes, it is the creation because we can see these are the owners, these are the signatures required. So from here we can see actually the parameters. If you go to the events, you will see the create event if you scroll a bit down, and there will be a contract address. So here it is, you can copy it. And after that, to make this thing verified, going back to Hardhat. So this is terminal in the Hardhat. No, it's not. Let me go back here. So what we could do here is mpx Hardhat, verify existing multisig, blah, blah, blah. I will leave this command on the screen. So if you run this one with the address that you picked up from the dashboard, it should verify your contract so you can see actually everything decoded. So if you get that glitch, you can rely on this command. So you can proceed by running the test yourself, play around with it, see why it failed, try to fix the test. We have, let's say, 20 minutes for this, tops.
No, account ID, well, that's a good question. Maybe you can do the, who am I?
No, I think it's like the username, which is the bottom.
But you're not logged in, so you can't run it. address.
If it is not verified,
It's not.
you should.
But then I just replace this address with
Yeah.
this one.
I know that's the multi-sig factory. You should be
Ah,
able to
okay.
this transaction over here.
So let's pick up the pace, and I will just go through some of the issues that are present in there. So the first one was, you saw it when I ran the test, it sort of hanged. It couldn't find account 5, and I would be lying if this was intended. It was not, but it was an accident. Yeah, something changed in the meantime. So one thing that we could do is actually what is happening in there. So the test, what it does, it switches to account 3. That's one of those that we loaded with tests ETH. And then we we did the interaction with the UI to create a new multisig with these 3 owners and 2 required signatures. And then what we did, we proposed a transaction, the one that's pure profit, just sending some value to an address, never mind which one. And then we're approving transaction as this first account, number 3. Then we're switching over to account number 4 for it to approve the transaction as well. And then we attempted switching to account 5, which for some reason didn't exist. So this can be easily resolved if you just replace this by either 3 or 4. Ta-da.
So 4 is the multisig?
Sorry?
Count 4 is the multisig?
No, it's just 3 different signers that we added. And in MetaMask, on that drop-down, they're called account 1, 2, 3, 4, 5. Yeah, there's no 5. So this is how it shows up in the MetaMask extension when you want to switch over the accounts. And what happens then, we're funding the multisig, and now that we have our 2 confirmations out of 2 expected, executing a transaction should go through. So now that I changed this, I can run the tests again. And is it on? It's on. And it does look a little spooky when you see your browser doing things with MetaMask, right? I think if we had like a wallet specifically for this type of thing, it wouldn't be so scary.
You should have warned us first.
That's
Big warning.
true. Yeah.
I'm like, what have I done?
Yeah, but honestly, it's happening in Chromium, so there's nothing, it's not touching anything of your stuff.
That's exactly what the thief would say.
I would never. Yeah, so now there we are, we're approving the first one, and second approval. And now we have the funding of the multisig because we need them to, and now it hangs, the execute never happens. So now if you open up the inspector, and if you go into the console, oops, I closed that one down, but we don't need it. We can see here that the contract function reverted, insufficient number of confirmations, cannot execute transaction. So this over here is sort of indicative that, yes, we did have 2, it appears we had 2 confirmations, but this thing fails over there for some reason. Now, if we go into the dashboard, and if I go into this latest run, well, I still don't have this verified, so let me go through that again. I will open up this transaction, multisig factory create. And I'm going to go into details because I need to get the address of the new multisig, and I can get that by opening events and scrolling down. I can see here, oh, get out. I can see here that there's the create event, and then there's the contract address. I'm copying it. And going back to hardhat, verify existing. So this little task that you can find in the hardhat config file, if I do this, now we have it verified. And moving back and reloading. So now we have submit, confirm, confirm, and those are the 3 successful ones that we saw in the UI, but there is a failing one, apparently. And I don't want to even go into the failed JSON RPC calls here because too many. What we can do is actually the next phase, and that's the local hardhat testing. So we've been through the local end-to-end, and now in the section 5, you can very quickly run hardhat tests if you haven't already. Anybody did the step 5 of the flow in the Notion? All right, so I think it'll take you like 5 minutes tops to complete that one. And there's no MetaMask popping up, I promise. Sorry? In And did you find a failing transaction? And did you find a bug? Would you like more time, yes or no?
I think just number of signatures required, checks somehow wrong. Suspicion is
Transactions. Yeah, it should be fine on the chain.
fix it instead of,
Yeah, I think that's it.
which line?
Unless the requirement is like, no.
The solution and the bug are very close, so I'll do the same thing. So right now I'm running the hardcat tests locally, and as you've seen, it's actually sending everything over to the DevNet. And while this is running, I will quickly go over that. Test. Yes, so these are practically the hardcat tests, and in this fixture or setup, what we're doing is we're deploying the multisig, so testing the multisig, waiting for it to get deployed. And from within the test, we're actually asking Tenderly to verify the contract so we could debug the transactions that are going on there. And there's also the funding transaction. And now we have a bunch of tests. The ones that we particularly care about is this one, because this one failed, or will have failed. Let's see, yeah. So accepts execution with required approval number. So this is the one. Well, this one fails. And to debug it, to figure out if there's an issue in the smart contract, we can actually hop over to the DevNet. And oops, this is the one. And enter the latest run. And now this transaction doesn't show up in this overview here because it has failed. But what we can do is we can find the, what is it here? The JSON RPC call that should have been that transaction. And if you scroll down a bit and skip over some of these JSON RPC calls, you should see here a failed ETH send transaction. And what the cool thing is, besides seeing all the information about that JSON RPC call, you can hop into the debugger, and from there you can actually see the message and jump exactly to the line where the thing failed. Now, I guess, and I assume that most of you already had the solution that this sign over here was off, but this was just we entertained this idea just to show you the way that you can spot the transaction that failed, the way that you can reach the debugger and, you know, have a little bit of easier time figuring out what went wrong. And one little tool that can help that is Evaluate, something awesome in 2023 that you can use to, well, evaluate expressions. So if I paste this here and hit Evaluate, we'll get the result, all right? And also if I modify this into a little array or a tuple by adding a comma and wrapping it into brackets, if I evaluate again, I can see that we have 2 confirmations, 2 required signatures, so this one should have been executed. And again, the fix for that is going to the multisig wallet contract line 159 and adding greater than or equal to sign, but there was also a solution in the Notion doc. If you looked for it, you found it. I just wanted to give you a little walkthrough through the tools that you can use in this process. So now, with the bug fix in place, if we run these tests, they should be successfully executed. There we go. The wallet is funded, and now it runs it one by one. It is significantly slower than running it on a local node, but it does give you the way to visually go through the issues and figure out what the heck is going on. And before the last part, now let's just wait for this one to, yay, all the tests are successful, so our job is done here. And now it's testing the factory, but we don't need to wait for that one. So that was all cool, but one question actually that I want to address before we go on to the last segment, and that's the CI, is how did Hardhat and frontend actually collaborate? Because you've seen that we had this, we had that script that deploys the contracts onto Tenderly, but how does the frontend learn about where the contract is? How does the frontend learn about the RPC, and how does it add the RPC in there at all? So let me just quickly open this up in my browser, so outside of the tests. Here we are. Here it says wrong network. So what you can see here, we use the Rainbow Connect, and here you can actually add the RPC, such as this one, as an option for connection. So this is test tenderly based on mainnet with a different chain ID. So if I click it, this is the first MetaMask pop-up. And you can see the weird chain ID we're connecting to. You can see the RPC link of Tenderly. So if I hit approve, that network will, okay, I need to also allow it a bit to switch. And now we are on that particular DevNet. So whatever you do here, for example, create multisig, it, whoops. When I hit create, well, this should execute, this should run. Ah, there we go. There's a confirmation and a little to it, pretty much done. So it's, when building UI, we're trying out UI, when doing some sort of testing, then this thing can speed it up and gives you a nice way to understand the issues coming from smart contracts when you're building the UI, so closing the cycle in that sense. And now the question remains from the technical side, how did the Next.js app, the thing that we're seeing here, how does it know about the RPC, and how does it know that the multisig factory is where it actually is? So the trick to that, the big question to that is actually, where did I put that one? Here. So it's a little bit annoying. It's practically the configuration management. So when you deploy a new DevNet from that Hardhat module, it spins up here, but you have to somehow let the front end know where that network is. And the second bit is when you run the deploy script, which is over here, the thing that you can't properly see, it deploys the contracts on the DevNet, but how do you let the front end know where the contract is? And one of the simplest way, and I can just show you how it's done here, in the deploy script, what we have here is after the multi-sig factory contract is deployed, we await for that, we verify it, and then we're collecting all the ABIs and the addresses and just simply plain out writing that file into the front-end repository. This is like the stupidest but the most effective way that I have found to achieve it. So, and if you want to have more elaborate config management schemas, go for it, and let me know what you do there, because I like to know. So this is the bit that ties the hardhead and everything to the front end, and yeah, it's somewhat important to make that happen, especially if you have like a separation of who in your team does contracts and who in your team does front end. This is just like a very super easy way to give them staged contracts whenever you develop something, or whenever you evolve contracts in a way. So that was the bit about the configuration management, and the next and the final segment that we have here. Setting up the CI. So I'm also assuming this won't take more than 15 minutes, and I'll give you like 10 minutes to do it, and then I'll walk around and bug you or help out if you get stuck. So the CI, I guess you've done it, or if not, it should be fairly straightforward. I would like to just briefly reflect on what we did, and maybe you guys have some closing considerations or reflections that you would like to share. So what we did, we used the tech of Tenderly DevNets, which practically allow you to take a network, spin up your own like private version of it, and you can customize it by using a little bit of YAML, a little bit of declarative style of configuration. So whenever you run either your local tests, whether it's smart contract tests or UI tests, or you're just running deploy scripts to test them out, to try them out, and to debug them, you can plug in DevNets in any of those workflows. And the cool thing is, because they are created on demand via CLI, you can easily plug it into the CI and have all that machinery coming together for your tests. Is there any insight or reflection or idea that you would like to share, or a question you'd like to ask? Doesn't look so. All right. In that case, oh, yeah, we have a question. Yeah, can you just wait for a mic, please?
Does Tenderly provide something similar, like a local Etherscan? I could I mean, I know the Tenderly way I can go through, but something more, let's say, simple, or like, is there something like that?
Like local Etherscan.
Yeah, basically for my spinned up RPC.
Yeah.
So, yeah.
Well, there is that bit that shows you all the transactions that are executing.
Yeah.
So if that's what you mean, there's that. There's also, like, in the DevNet, you have a simulator practically calling contracts, either write or read methods of the contracts. So in that sense, it allows you to look at what's happened and interact with the contracts in a simulation sort of manner. Yeah. Is anybody closer to writing more tests in the future? Yeah, okay. I see a couple of people smiling, so I take that as a yes. Yeah, we have a question there.
How do I add funds, testing funds, to some specific addresses?
Sorry, can you bring the mic closer?
Yes.
I couldn't hear you.
Can you hear me now?
Yes.
How do I add testing funds to my keys, like before testing suite starts?
All right. So you would do that. Let me just go back here. So one thing that you have in your YAML configuration is like this section called wallets or contracts or whatever, and you can provide either Yeah, this is what I'm showing. So you have this wallet section in the YAML config. So there you can either set up balances for the private keys or for the addresses of the wallets and contracts that you want to top up. And let me show you just another bit in here. So what you can actually do is you can override the storage slots of particular contracts. So set an address, get the hex of the storage slots. For now, it's just a hex, and the value you want to override it with. Also, you can override the ERC20 balances. This is the ERC20 contract, and I want to set that the address 0 has 100 dies, for example, in a DevNet. So in this way, you can do customization in that regard through the YAML file only.
And there is a button in the network that says fund account. So you can
Yeah, there's also that.
Awesome, thanks.
Yeah, so here, for example, if you look at this, you can just paste an address and it bumps it up. We have another question here.
You also have a ERC20 faucet, like for example, for USDC. In theory, you could manipulate the chain like that, that you can give yourself USDC.
You can manipulate the DevNet chain, the one
Yeah,
that
yeah,
we're...
that's
yeah,
what-
yeah, yeah,
yeah.
yeah, yeah, yeah. So in that YAML file, there was this little bit, now it's out, but let me open it again. There's this little bit ERC20, so you can actually set the amount of ERC20 for particular addresses.
Okay, thank you.
So this address, that much.
And also,
Yeah.
like, during the customer procedure, for example, increase time of node, change anything, any configuration for that is really cool. For example, for some proposals, testing, change states, something similar. So writing complex scripts there.
So you support all the hardhead EVM commands?
Yeah, and even more. Like there is even more like custom ones, which is technically specific. So yeah.
Yeah, I'm just trying to open up those specific JSON RPCs that we have. There's, for example, add balance, set balance RPC, so you can do it via an RPC call. There's increasing the timestamp. There's increasing the block number, so you can actually tell them, hey, pretend like 50 blocks are mined, and now receive my transaction. So stuff like that. So it gives you really a lot of tools to play around with the actual thing.
Yeah, you can imagine it as like main a copy or supported a copy that you can, like your own copy of that network that you can configure in any way. So like a local version of mainnet.
Yeah, so these are the funky ones. All right, we have 1 more minute, so I think it's time to wrap it up. Thank you everybody for the workshop. Thank you for the patience and for waiting for NPM to install. Hope you had fun, and hope you do more testing in the future in a pleasant way. And would like to talk to you guys on a coffee break or something if you have ideas or want to share impressions. Highly appreciative of that. So thank you very much, and enjoy the rest of the conference.
Hello, everyone. So my name is Manos, and we're going to talk about Olas and how you can build and monetize your decentralized AI agent in Python by participating in a hackathon that we're organizing. So first, we're going to discuss about what Olas is. We're going to talk a little bit about the prediction agent hackathon and what it is. And I'm going to demonstrate how you can run and refine your own prediction agent in order to participate. So I'm Adamantios Zaras. I work as a Python engineer at Valory. I have a data science background, and Valory is the company that is behind Olas. So what is Olas? Olas is an ocean of decentralized services for crypto. And what kind of services? These services range from oracles to AI, messaging, and more. So Olas has a protocol which coordinates a community of developers to build those services. It uses the Olas token, and let's see what Olas is composed of. So Olas is a protocol, and on this protocol you can register your code. It also coordinates the actors, and you can get rewarded from it. It also has an open source framework. It is the Open Autonomy Framework. And using this framework, you can build those services that we mentioned, and you can also register code to the protocol. And it is also an ecosystem of running services and code, and those services provide value to the end users. So here we're using the term autonomous services. And this is the special type of services that runs on Olas. And we're going to discuss about this now. So what is an autonomous service? An autonomous service has broad applicability in running everything from relays, messaging, AI tools, and more. These can be applied in fields such as DeFi, NFTs, decentralized social, etc. Autonomous services offer a unique set of tools to developers because they're crypto native, they're flexible, and they're intelligent. They're crypto native, unlike web services or other centralized solutions. They're flexible, unlike current contract and Oracle's automations, and they're intelligent and capable of running powerful and long-running computations. An autonomous service has a robust architecture, and you can see on a high level the architecture on the picture on the right. So the service is in the middle, and you can see the service consists of multiple agents. Each agent is operated by a different entity, and those services can perform computations, as we mentioned, such as they can run AI models, and they use Tendermint in order to come into consensus about their actions. The service is represented by an NFT to the protocol, and the agents of the service can pull data from any source. It can be Web 2 or Web 3 sources. It could be IPFS, a ceramic stream, anything. And they can also submit transactions on chain, and they do that by using a safe multisig on which each of these agents is a signer. The Olas ocean of services is already in full swing. There are already more than 100 services registered on the protocol. They have performed more than 60,000 transactions. Olas has collaborated with some of the most reputable names in the space. And there are already some services in all of those categories that you can see. So Valory, the company behind Olas, recently collaborated with Gnosis Chain and Gueiros, and they participated in order to build a project that utilizes the stack, the Olas stack. This project, I'm going to give you an introduction about this project and why you might want to participate and how you can get easily started. The project is called the Prediction Agents Hackathon. We have developed an autonomous AI agent that participates in prediction markets. And why would we do that? Prediction markets are one of the oldest applications on the crypto space. However, they require expensive human reasoning. Staying on top of and making accurate predictions is a costly skill. Sorry, give me one moment. So staying on top of and making accurate predictions is a costly skill. And as a result, prediction markets adoption has suffered. Right. However, with low-cost chains like Gnosis, with protocols like Olas, and with recent advances in AI models, we recognize that there might be a new opportunity. Therefore, we set out to test whether we could transform the economics of prediction markets by using decentralized AI agents in order to participate in the prediction markets instead of humans. And therefore, the Prediction Agents Hackathon was created. You can also get involved in the hackathon. You just need to clone a repository, run a simple command, and you're away. You can also make changes to your agent strategy in order to outcompete other agents that are participating in markets. And you can also submit changes to the code base and get rewards. So the rewards are the following. Gnosis Chain is rewarding the best AI mech tool. And we're going to discuss what an AI mech tool is next. Valory is rewarding the best prediction agent adaptation, and this means the best code change to the agent. And Gueiros is rewarding the best performing agent, so basically the one with that produces the most value for itself. Now we're going to discuss about how you can run an agent first. But first, allow me to introduce you to the AI mech concept. So a mech is an autonomous service that we have built. A mech receives requests on-chain. It performs some operation like running an AI model, for example, and it posts the response on-chain as well. The mech service has a large set of tools that someone can call by making this transaction request on-chain. The prediction agent that we're going to discuss about is using a specific tool of the AI mechs in order to run. So let's discuss about the steps that the prediction agent does on a high level. The prediction agent first needs to pull all the data for the prediction markets from the Omen platform. Next, it needs to sample one of those markets. Currently, it samples the market with the highest liquidity. This can obviously be improved. Next, after it has sampled one of those markets, it needs to decide what it should vote for and whether it's profitable to vote. So it does this by calling the MEG tool that we discussed about. So it sends a prompt that contains the question of the market and the potential choices to the MEG tool. And the MEG tool responds. The prediction agent reads the events on chain and picks up the result. Next, the prediction agent needs to calculate whether voting for what the MEG proposed is profitable. So after taking that step, if it is profitable, then it simply votes. If it's not profitable, then it blacklists this prediction market for a configurable amount of time, currently for 1 hour. And finally, after doing those steps, it checks if it can redeem some of the positions to get back some rewards. Now, let's go to the trader quick start that we have linked in the presentation. As you can see, we have set up this repo. It has all the instructions that you need in order to run your first agent. We simply need to clone the repository. And we also need to make sure that the system meets those requirements. So we need Python 3.10, Poetry, a version that's larger or equal to 1.4.0. We need Docker and Docker Compose. So I'll do that on my desktop. All right. So let's clone the repository. Is there a different SSID than the one? I think. Yeah. Can someone read the password? OX. DB 10C. All right, thanks. Let me try again. So is it supposed to be that way, or?
Sorry? Do you want to use my Wi-Fi?
Sure, if you're, yeah. Which one? All right. Oh, sorry.
It doesn't matter.
Don't go in. I trust you guys.
All right, that was fast. All right. Now we're into the repository. As you can see, the only thing that you need to do is make the script executable and then simply run the script. And let's do that. So the first thing we notice is that the script requires an RPC in order to run. So what we suggest is that you get it from getBlock. And this is, the reason is because getBlock supports ethnew filter, and we haven't spotted yet an RPC that supports it, another RPC that supports it. I have created a demo project here for now, and we're going to copy this RPC. I'm going to input the RPC into the script. The input is hidden, and I'm going to press enter. Now the script is going to basically go through all the steps that are required. It's going to clone the trader repository, and it's going to automatically generate some addresses. These are the address of the service owner that is going to own the service on the protocol that we are going to mint soon. The script will do this for us. And it also generates an address for our agent. So the script now is waiting for us to fund with 5 cents the auto-generated address of the operator in order to be able to mint the service to the protocol. Let's send that amount. All right, let's wait for the transaction to be validated. All right, it's already picked it up. It has seen the balance, so it started minting our service. So it's first going to go through the activation step for our service. Then it's going to register the agent instance that it created to that service. After registering the agent instance, it's going to deploy the service, which is the final step. All right, so our service is on the protocol. Now we need to fund our agent, which is going to pay the fees for the transaction. And we also need to fund our safe. The safe is going to basically spend the amounts for the bets. Let's first fund our agent instance. I'm going to send 0.5, oh, sorry. I'm going to send 0.5 XDAI. Let's speed this up. All right. And last, I'm going to send some funds to the safe. I'm going to send about 1 XDAI or 1.5. All right, so now we're waiting for the script to pick this up, to pick the balance. It's been confirmed. Let's wait for the script. All right, great. So now it will set up our service. It's going to use Docker for that, and Docker Compose. As you can see, it's already started creating the containers. It's first creating the container for the agent, and next it's going to create the container for the Tendermint node of that agent. All right, so the service is running. It's running in the background. As you can see on the quick start in the instructions, there are some commands to get you started. For example, you can investigate the logs of the trader. So this might be overwhelming if you're just getting started, but I'd like to show you how this looks. And I'm going to remove some unuseful information, and we can focus on the rest. All right, so let's go to the top. These are some framework-related things, so we're going to focus on the rest. As you can see, this is called the update bets round. This is where it fetches all the information that we mentioned. And you can see here all the market's information. Next, it's the sampling that I mentioned. It just picked one market. Next, we can see the request to the MEC. So there's a link here. If we click, you can see on IPFS the prompt that we sent to the tool. You can see the tool that we requested to use, and there's also some unique ID for our request. And next, we can see here that we're sending basically the request to the MEC. We're sending the transaction. And now, at this point, our service was waiting for the MEC to respond. So it basically filters the events. And as we can see, it picked up the response to our request. Here, we can see the response from the machine learning tool, from the LLM. We can see the probability for the yes for the market. We can see the probability for the no answer for the market, and we can see the confidence of the model. We can also see what is called info utility. So this is the percentage of information that it used online in order to make the prediction. So what the tool does is it enhances our prompt with information that it picks from the internet. Currently, it uses the Google API to fetch some news and add those to the prompt. And yeah, 0.6 is the percentage of information it used online, and the rest is just the knowledge of the model. So here we can see what the prediction agent did. So it says that it first of all mentions what is the liquidity of the market. Then it says what's our potential profit from placing this bet. And it says that the profitability the decision for the profitability is true. So we're placing the bet next. Let me fast forward to that. This is the transaction. You can see this is our hash. And let's take a look at the transaction on GnosiScan. Let me take a few. Nope. All right. There it is. Now let's see that transaction. If you go to the logs, you can see, first of all, the amount that we sent, the amount that we have placed, the amount of the bet. This is the market on which we have placed the bet. And if you go to the creation of the market, to the transaction of the creation of the market, you can see what actually, which market was the one that we placed the bet. And this is the question that you can see right there. All right, so this was a high-level overview of the logs, but there's obviously an easier way to do that. You can do that only if you want to be on top of and basically verify for yourself what's going on. But we have created some scripts to easily do that. Let me first, here you can see the command for stopping your service. So let me first do that because it's running in the background. So let's stop the service. While it's stopping, I am going to show you those commands that I mentioned. So first of all, there's the trades.py script. Let's copy that. Let's paste that on the terminal. And let's replace with our safe address. All right, let's paste that here. Oh, I'm already in the repo. All right, so as you can see from the output, the script simplifies things a lot. It outputs a link to the market that we placed the bet, so you can see what it was on their UI, on the Omens UI. It has the question of the market. It has the amount that we bet for and how many conditional tokens were bought. And we can see the fee that we paid to the market. And here it says market not finalized. This means that it's still running. And if it's finalized, then the trader agent is going to redeem the amount if your position is winning. To the bottom, we can see a summary. We can see how many trades we have performed. We can see the amount that we have invested, the fees that we paid, the earnings. So far, it's 0 because no markets have been finalized, and what amount we have redeemed. The next thing I would like to show you is how you can keep track of the MEC requests and responses. So if you go to the aimex.autonolas.network, there's a tab called MEC. And here you can see all of the request IDs, all of the senders. So you can basically find your safe's address in the senders. And you can see the request data and the delivers for that request. So if we see the first one, for example, you can see the prompt, the tool, and the unique ID. And you can see the response for that. It's that easy. You don't need to go through the logs. And last, if you would like to take a look at what your service is doing, you could check the state transitions, as it is called. So you can run this command, and this will print all the transitions on which your service has entered. So you can see that it has completed 2 periods. As we say that, it's how many times it's repeated the same procedure. And you can see that it has placed a bet during the first period. It has not redeemed anything yet, and the same for period 1, for period 2, etc., etc. You can monitor your service easily with that command. Now back to the slides. So something else that you can do is you can improve your agent strategy. One easy way to do that would be by editing some environment variables. So let's go to the trader repository. So if you take a look at the folder called packages and then the Valory package, you will see that there's a folder called services with the trader service inside. And there's a YAML configuration file. Inside this YAML, you can see a ton of configurations, but we can focus on the trader-specific ones. So an important one is the MEC tool. Here you can see which tool is being used by default. You can also see the bet amount. So the bet amount depends on the confidence. So intuitively, if you take a look, if the confidence is up to 0.5, we don't place a bet, but you can play around with these values. So above 0.6, we increase the values that we bet for. You can also see the bet threshold. This is the amount below which the service is not going to bet because it doesn't consider it to be profitable enough. And another important one is the prompt template. Here is the prompt that we send to the MEC tool. And as you can see, it has some parameters. This is the question of the market, what represents yes and what no, because even though the markets are binary, it could be something different than yes and no. It could be blue or green, the answer. So it also needs those parameters. And these are populated by the service. So let's take a look at an example. So I'm going to show you what I've done in my trader. So if we open the script that I mentioned before in the quick start, you can see, if you go to the bottom, you can see that there are some of these environment variables hard-coded in there with some default values. So I have changed the prompt template here.
Sorry, can you
yeah.
zoom in a little bit?
Yeah, sure.
Sublime, right?
Yeah, of course.
Yeah, thanks a lot.
Is that fine?
Perfect.
All right. So as you can see, here I have edited the prompt template on my service. So I've changed the prompt a bit in, as an unbiased QA expert, please provide the probabilities of per yes and per no occurring for the question. Here is the parameter. If the yes option is represented by yes and the no option by parameter no. So you only need to change the environment variable in the script, and then you can simply, let's go to my agent. And you can simply run the script again. The script has already stored the necessary information like the RPC, your agent address, your safe address. You don't need to provide anything again. It does the balance check here. So as you can see, my agent does not, my safe does not have enough balance. So let's send some die there. I'm going to send about 1 X die when MetaMask detects the address. All right. Let me do that 0.8. Let's make that aggressive. All right. And now when the service picks this up, it's just going to spin up the service again, and the environment variable will have changed the prompt that our prediction agent is using. So you might see this message. So this is in order to remove the previous build. It's safe. It's only going to delete these folders that are mentioned here, some Docker-related information, and it's going to regenerate those. And as you can see, it's already starting again. All right. Now it's running again. Let's take a look at these logs. Starting, it's picked up the markets. It sampled the market. Let's wait for the request to the MEG. It's already been sent. Here it is. Let's take a look at this request. Let's go to Gnosis-Scan, paste that hash. Let's see the logs. Let's see the data. Let's go to IPFS, paste those data. And now we can see the prompt. As you can see, it has changed. It's not the prompt that we used previously. So it's relatively simple to tweak your strategy by editing those environment variables. However, tweaking those environment variables might not get you too far. So in order to improve your strategy, you might want to improve your expected net profit. So the expected net profit is defined in the following way to the service. So it is the number of tokens that we have obtained. The number of tokens is a function of the bet amount that we have placed and the market on which we have placed the bet. The bet amount depends on the confidence. So as you can see, the confidence plays a big role. So by tweaking something that would change the confidence, we could end up with a much better expected net profit. After calculating the number of tokens, we subtract the amount that we used for the bet. We subtract the fees, such as the value that we paid to the MEG for the response, and such as the fees that we paid to the prediction market. And finally, we subtract this threshold that I mentioned before, which was in the configuration. And it's there because the user might not want to place a bet if it's below a specific amount. So in order to have a better strategy, you could refine the code in order to improve the confidence and the results from the tool. So I'm going to demonstrate how this can be done. As you can see, this is the repository for the MEG service that I mentioned before. Inside the MEG service, there's a folder called Tools. In this folder are all the implementations of the tools. And here you can see there's one script. It's called the prediction request. And this is what we are currently using in the prediction agent. So let's take a look at this script. You only need to know how to code in Python, and this abstracts away everything, all the knowledge you need to have for the framework. Let's take a look. Here we can see the names of the tools that you can use from this specific script. As you can remember, if you remember, this was in the request that we sent to the Mac. We can see the prompt that it uses. So as you can see, it enhances the prompt a lot. It adds a lot of things. And here is where the user's prompt is entered. And here are the additional information, which is the data that we fetch from the Google News API that I mentioned before. And if you go to the bottom, you can see the main function. It's called run. And all the tools need to implement the run method. Let's take a look. It's relatively simple. So what it does is, it first of all, it picks some values like hyperparameters, etc., like the temperature of the model. It sets the OpenAI key and some things. And then what it does is it first fetches the additional information from the API we mentioned, and then it adds this in the prompt. Here's the user's prompt, as you can see. And here is the, by the way, can you see that, or should I zoom in a bit?
Yeah, it would be good to zoom in.
All right. Is that okay?
A little bit less.
Less? All right. Is that okay? All right. So it creates the prediction prompt by using the user's prompt and the additional information. And then it simply creates, sends a request to the OpenAI API and gets the response. So one thing you could do to improve your strategy would be to create a new tool. And let's take a look at one of the tools that was submitted recently. So on a high level, what they did in this PR is they introduced a concept that is called subject matter expert. And what they do is they basically enhance the prompt that they send to ChatGPT by using specific specialized prompts depending on the subject. And how they do that is they first send a request to the OpenAI in order to understand what the subject is. And then they enhance the prompt by using this information and send the final prompt that has been edited to OpenAI and get the response. Let's take a quick look at this implementation. So here, as you can see, they just get this configuration of the prompt, but let's go to the main part of the implementation. Here is where they generate the subject matter expert prompt. And as you can see, it gives some examples for task questions, for subject matters, and here is how it's going to be extended, how the prompt is going to be extended. And finally, let's go to the run method. So as you can see, the only change that there is in the tool is that now we have this enhanced prompt that we are using in order to send the message to the OpenAI API. So after creating your tool, then you could submit a PR. We're going to review this PR and merge it, and we're going to publish your tool. And then what you can do is, let's take a look at the script again. Let's go to the trader repository. And here, if you remember, we have this configuration. We have the mech tool. Here, we have an environment variable. It's called mech tool, as you can see. And here, the value specifies which tool we are going to use. So if you open the script, here are the environment variables. You can basically put that wherever you want. You could even put that on top of the script. It doesn't matter. So let's export the value of the mech tool. Let's change it. And let's use the subject matter expert one. Let me go to main. Let's go to the tools. Let's go to the subject matter expert request. And here we will copy any of these tools. So the normal one uses GPT 3.5, and the strong one uses GPT 4. Let's copy the normal one for now. And we will paste the value inside our script. And then let's stop the previous service first, because it's still running. And when the service stops, we're going to rerun it, and it's going to pick up the new tool. Oh. Now we're running the service, and while it's starting, since we're running out of time, let me continue on the presentation and get back to it. So today we have talked about Olas. We have discussed about what an autonomous service is, and about the Autonolas Protocol, about the Olas ecosystem. We discussed about the prediction agents hackathon and how you can participate, what the prizes are, and how you can simply participate by changing either configurations or developing your own tool and submitting that. And here you can see a QR code. You can scan it for the Olas links, and it would be nice if you could also participate on the survey that we have for the workshop and what you think about it. It's inside this link. Let's take a look at the service. It's started, and let's see the logs one last time. So this is the request ID. While this is loading, would you like maybe to ask any questions? So All right, I think we're running out of time. And the MEC needs some time to respond to this. So any questions on how you could create the tools or where you could submit it or anything? Otherwise, all right. Thank you.
Okay. Thank you, everyone, for coming. Every one person. So I'll turn this into an artifact or record for the viewers at home. And we'll probably skip quickly through some of the exercises that I had planned in case a larger group attended. And we can customize this to the folks that are here right now. But yeah, we're going to talk today about legible authorization, AKA nailing UX without sacrificing security. If you feel like scanning this, there is a copy of the slides and a fig jam that we might hop into to assemble resources, and I'll make sure that after this, anything that comes up from y'all's questions, I have a litany of links to relevant stuff, so I'll make sure that there's some kind of take-home reading here. The TLDR is that for a long time, it has been often said that usability and security are in tension with each other. But for just about as long, actually, there's been a good thread from the HCI community and onwards that, in fact, the opposite is true. The more usable that you make your systems, the more secure they can be. So these things work in tandem with each other. If you feel like it, you can just share a bit about yourself in the document there, and that'll possibly speed stuff up later. But are either of you a designer or more on the engineering side? Developer. Yeah. Okay, cool. So I myself am a designer, and sort of to give you my bona fides, I guess, I first connected to the internet in 1988 through a 1200 baud modem, and over the course of the preceding 30-something years, I've seen a lot of things. Presently, I lead design at a company called Fission, so we build local-first identity data and compute infrastructure. I'll talk briefly a bit about like some of the work that we're doing right now and why it has led me down this rabbit hole of making authorization more legible. So we have a few things. Some of them you may have heard of. We're the authors behind local first authorization protocol called UCAN. We work pretty extensively in the IPFS ecosystem. We brought encrypted data to IPFS through something called WinFS. We're now extending the capabilities of that to provide compute over data in something called the interplanetary virtual machine. And so, of course, when you're passing payloads of data around, you want to make sure that folks are authorized to do only the right things with that data. And this means that, whether it's to developers or the end users, there's a lot of moments of authorization that need to be made legible there. We're currently focused on trustless off-chain distributed compute. And we also have, for client-side devs, something called Odd, which is an SDK, JavaScript based for the web right now, but also coming to native mobile, that makes it easier to work with those low-level protocols without needing to wrestle with the details. I also am here as a representative of CASA, the Chain Agnostic Standards Alliance. So that's where the working group that I facilitate right now, the Secure Design Working Group, houses our discussion. You can find it under their GitHub repo. A lot of folks there from wallet clients, the Wallet Connect team, MetaMask, Brave, et cetera, working to attempt to align on standards, many of which have been implemented today. So if you ever are dealing with chain IDs, that came out of CASA as a thing called, we call our improvement proposals CAPES. So that was CAPE 2. We'll touch on maybe a couple of other interesting capes in a bit. But the thing that initially bothered me about the state of the industry right now, which I'm sure is like a non-controversial opinion, is that wallet clients and dApps work the least for people who need them the most. They still rely on a very deep technical understanding. And while not precisely blind signing, you're often completely unaware of what the contents of a message are. you're just trusting, you're depositing trust in the person who initiated the signature, right? We can do better than that. But we often beat ourselves up and we say that Web 3 is not yet as good as Web 2. Like, password managers are fairly broken as well. You know, I've had to help a family member with dementia manage their accounts, and like, good luck getting somebody with that cognitive capacity to benefit from the security that a credential management tool is meant to provide, right? It's just not integrated enough, right? So another one of my favorite examples of this is 1Password. If you have to go through the recovery flow, they've obviously done a lot of UX research on where people are depositing these things, and the first place they ask you to look is in the downloads folder of the computer that you may have lost, right? So the failure case is happening really, really like early on, and it's you know, whether you think we're in Web 1, 2, 3, or 5, I don't think that we've got all of the you know, component pieces in place. We're still not at the first major 1.0 milestone for what would be a complete and usable system. So you got to make people empowered with information. They can do the right thing with their data. And we're at the point where a lot of that is possible right now, but it is sure as hell not probable. We focus presently on removing a lot of bad friction, but I think we also need to consider that there are elements of good friction that we should preserve or maybe even expand upon. So today we're maybe going to dig into a little bit more on what those points of good friction are. So my first question to the crowd is, and this is probably an easy one, but the difference between authentication and authorization, because this is sometimes not widely understood. Does anyone want to give an answer? Yeah?
The first one is who you are, and the second one is what you're allowed to do.
Boom! Nailed it. Yeah. So I especially on the, for anyone who's coming into the space from a non-technical background, I don't think that we sort of introduce this important distinction right off the bat, right? Auth-N, who you are, auth-Z, what you can do. And often who you are, you know, like we talk a lot about identity. I think it's very important for us to be precise and narrow about what we mean in that in this space. We're talking about functional identity. We're not talking about like emergent rich identity, like who you are as an individual. We're simply talking about like a provable identifier of who you are, right? And that can have a lot of different flavors. We can do anonymous ones. We can do pseudonymous ones, which everyone is now saying pseudo-anonymous. I think just to make that concept a bit more legible to folks. There's identifiable records, and then there's verified records, where I've actually provably attested to the fact that I am such a person. But back to auth-Z, does anyone want to try to list the 3 categories of authorization that typically are used? I'll give you a hint. The first one is access control. Can anyone think of a second one? It's a good term. And maybe I'll just skip to the slide. Rules-based access control and object capabilities, both of which could deal with some other terms, which you know, often we refer to these things as permissions, and that tends to be more often than not the user-facing term. We also talk about these things as privileges. And we talk about these things as capabilities, right? And so sort of the first authorization approach that happened in the history of computer science was access control. This was to govern timeshare of the mainframe at, like, you know, academic institutions. and you've signed in with a password, and every individual person was identified and granted access. That's obviously unsustainable when you hit large numbers of people, so then you introduce this layer of abstraction called roles, which allows you to reduce the number of security policies in your software. But there's this other lesser explored approach called object capabilities, which attempts to encode the authorization into a token itself that is shareable, subdelegatable, and works offline at the edge without needing to connect with like a central authority to determine who's allowed to do things. And it's our opinion at Fission, and I know a lot of other people in the space share this, that the capabilities are a fantastic path forward. And you can emulate, from a management point of view, the same sort of screens and workflows that you would be used to with roles-based access control. Anyone want to guess what the first moment of Dapp authorization is in a typical flow today? Like, if you're going to go use a Dapp, what's the first moment where you're authorizing it some capability?
Connect wallet?
Yeah. And what are you authorizing there?
The address.
Correct. And then what do you do next? Correct. By signing a message, right? And so presently, that's a little bit of like a wonky flow, because especially if you're doing it on mobile, and you're doing it through Wallet Connect, and this is surely no fault of Wallet Connect at the moment, you have to hop over once, select your account, hop back, wait for that to be confirmed and for the RPC data to be fetched, and then you hop back again, and you get a sign-in with Ethereum prompt or an old school, like, bunch of hexadecimal stuff, and you sign that, and then you're back again. So these are some of the capes that we're working on right now, which I think are going to be really powerful if you're on the Dapp side. If you're on a wallet client side, please take a look at supporting these on your end. But Cape 25 and 27, which would allow for feature detection. So if there are specific networks you're going to need, specific RPC methods that you're going to need to use that would otherwise break your app, Cape 25 and Cape 27 let the Dapp express that to the wallet client so that both the wallet client and the Dapp can provide more useful next steps back to the end user to say, oh, you're going to need to use a different wallet, or perhaps you're on an outdated version that you need to make sure you've updated to the latest because this is making use of a specific new RPC and method that otherwise the Dapp can't function without. Cape 222 is really cool because if folks align around that, it'll turn those two steps into one. And I'm just a designer, so I won't explain how that works because I don't honestly know. But I urge you, if any of this sounds interesting to you, to go check out the discussions on that. From the design point of view, these are three of the sort of key cornerstone papers that I, for whatever reason, made up the term pyramid of secure design to describe. But they are where a lot of the principles that guide us at Secure Design Working Group emerge from. Specifically, like the user interaction design for secure systems is a phenomenal read. But all three of these, if you haven't read them, I encourage you to. Within those three papers, there are if you add up all the principles that are proposed, you're at around 20. That's too many for someone like me who's simple-minded to remember. So I attempted with our group to distill this down to 7 guiding principles, some of which are not just about legible authorization, but about other aspects of it. We'll winnow that down to 4 or 5 of these for the discussion today. They are as follows. I'll quickly go through them. One, super non-controversial. Things should be easy and obvious. We know that human in the loop is like where things often fall down. And if things are complicated, then people are going to find a way to make the system easier for them, right? This is often what results in people writing passwords on sticky notes. The stricter you make things, if you don't make them also easy to adhere to, you're going to really weaken your system, right? I'm not sure if it 100% belongs in this category, but I see a lot of dApps presently still don't honor EAP 1271, and in our push to move to a smart account-based world, this is absolutely critical. Session keys are a knife that cuts both ways, but obviously delegation of authority to the browser to do things without needing to hop back and forth constantly is very compelling. We're going to have to be careful about to what degree and how we let people sub-delegate. And then persistent state across devices and sessions is something we still don't really handle very well. Safe does some of this. I was really interested to learn the other day, actually, that there's a tab, I didn't know about it, that will persist the off-chain messages that you have signed across all of your sessions. This still obviously needs to route through sort of a centralized system, but keeping access to that stuff is going to be really important for us moving forward, so that we can provide better risk management opportunities to the end users. Number two, stuff needs to be maximally de-risked before it is launched, right? We also non-controversial, we do audits on stuff. But there's a lot more that we can be taking care of before it ever gets to the responsibility of the user themselves. Here, there's a lot of flagging of suspicious transactions through registries or evaluation of the payload itself or domain binding. You also have transaction guards and spend limits that you can apply to things like safe. We do simulation. A whole bunch of things there. But when it comes to the person themselves, and this really ties back to the session key question, we need to find the right granularity of expressing the request for permissions, right? This part is tough because you don't want to overwhelm people and nag them constantly and lead them to become habituated to just say, okay, okay, okay. But you don't also want to overwhelm them with so much detail up front that they either panic and back out or say yes to more things than they should have or needed to in that particular moment. A bit later, we'll look at some precedents from the Android ecosystem, early research there that deals with that. For this step, interesting things for you to look at. UCANs, Cacaos, recap from Spruce ID, which is the authorization extension to their sign-in with Ethereum project. And then Dan Finley from MetaMask has put together an on-chain set of Solidity contracts to achieve, a set of Solidity contracts to achieve on-chain object capabilities that is called Delegatable. And that's still a very early project, but I know he's putting a lot of effort into it and finding ways to fund a larger team. So definitely some interesting stuff there. Things, of course, need to be sufficiently legible. I shouldn't need to be technical. Here, we got great progress with Seaway. There's some groups looking at human-readable messages at the moment, and there's a bunch of different strategies there. Things should be sufficiently auditable. This is somewhat solved, but not human-friendly for anything that happens on-chain. Of course, I can go and I can look back. I can go to revoke.cache. As I was mentioning earlier, Safe's messages tab is an interesting approach to knowing what off-chain messages I've signed and perhaps providing the clients or other services opportunities to flag things that they may want to reconsider or revoke or overwrite. And then we also need to be aware that things change, right? This is the common complaint about EOAs, obviously, is that if you do something wrong in the beginning, the only safe thing to do is abandon that account and at great cost and effort, move things to a new one. Here, obviously, there's a lot of great work on the smart accounts front. There's some interesting proposals, E5003 and 7377, which each describe different hard fork required approaches to migrating control of an account to a contract while retaining your public key address. And last but not least, if you've handled all that stuff, you still actually need to let the person do what they want to do, right? Like, so you need to thread the needle and ensure that, like, whatever they were intending to achieve is still possible, as long as it's a thing that they should seek to achieve, not sign a phishing message or something like that. So the first exercise that I was going to do was for all y'all to just share something about the authorization problems that you have. Did anyone come with a live problem?
Maybe.
Yeah. What's the problem, if you're willing to share?
We have a Dapp, and many of our users are not Web3 native.
Right.
So all of this sign stuff, Insta, MetaMask, that's just too much. And I think if we want to address a larger audience, it will always be too much. So we just integrated Web3 auth, which creates an EOA that lives somewhere, and the private key is assembled in the browser. But I wasn't very satisfied with the structure Web3 auth using this by itself. So we augmented it by creating a key share. We asked the user to store on their computer.
Mm-hmm.
And that improved things a little, but still I consider it less secure, slightly less secure than a hot wallet.
Right. And yeah, okay, so just to repeat the question, or the problem. You got like a mass market Dapp for whom asking them to install a wallet client like MetaMask is perhaps a bridge too far just to get started. And so provisioning non-exportable keys in the browser through Web3 auth, but extending that a bit further to get them to download and self-custody a key share. And I can't remember Web3 auth is like BLS. Is that how it's working? Like it's an MPC-based approach to stuff?
MPC-based approach, which I couldn't audit, so I didn't use it. I used the older version, which is called T-Key. It was developed by Taurus, and it uses Shamia's secret sharing scheme.
Right. Yeah. So, and this is where like it kind of gets back to that initial account recovery issue that 1Password kind of drops. It's probably wrong of me to accuse them of dropping the ball, but there's like this the moment that you have to ask somebody to take this data and do the right thing with it, yes, like you've already lost, yes, basically. Yes. And there, I think some of the most interesting possibility is the passkey standard. So for provisioning, maybe like sponsored contract accounts, smart accounts, there are experiments at least, they probably need to get some more eyeballs on them, where you root control of the contract account in a WebAuthn FIDO Alliance passkey. Are you familiar with the passkey standard? No, it's super interesting. Go to passkey.energy, which is another like sort of weird living documentation site that we have. It works perfectly for your needs in Chrome, on desktop and Android, as long as you go into the settings and turn on a feature flag. It could work broadly across all browsers, and it is on a standards track adoption at the moment. But this would allow both signing key material and derived encryption key material to come from passkey. What's cool about that is passkey is already being adopted as a passwordless credential for signing in to like huge, recognizable household brands. Like in the United States and Canada, there's a big company called Best Buy. They're integrating this stuff. I think that you can already use passkey to authenticate into Google's services. iOS has first-class support for it.
I still don't get what it is.
It's just a passwordless credential, right? So it's like, again, just a designer, so I'll lose the words, but it's public key infrastructure that is built into these operating systems at a first-class level that you could use to provision on-chain accounts. And then, if you did it that way, and everything works, and we all agree it's secure, theoretically, that person just ends up, like this will be the way that people authenticate into all services and websites within the coming couple of years.
How does it work?
I urge you to check out the demo. Yeah, go to, I think we have links to some of the other demonstrations from passkey.energy. And there you'll be able to try creating your account through a passkey. And then that will be synchronized across, if you were like I myself am a 100% Apple person, because whatever, I'm a designer. And those passkeys will be synchronized across everywhere where I'm signed in via iCloud, right? So it's not, for a certain threat model, what you want to be doing is it's non-exportable from your device. To a certain degree, that device may mean that it is syndicated across everywhere that you are connected in your sort of personal cloud of devices. If you're cross-ecosystem, you can do a device linking QR code-based flow. So I could still have my keys domiciled on my phone, and the authentication handshake can happen via a QR code so that I could sign in on a desktop or anywhere else where the standard is supported. And again, it's like the latest version of major OSs and browsers all now support passkey. We need a couple more things to happen so that we can use it as the root of entropy for encryption as well. But yeah, for like signing, it's good, and there's some people exploring how this would work in this space, right? And then, so then the only question is later on when I've got like more stuff and I should maybe be a bit more careful, and you tell me maybe your threat model is sophisticated enough where you don't want to have that key material encrypted in your iCloud. Sure, like now let's add a separate signing factor, like I'm aware enough, I've been doing things for a while, and as we progressively enhance people's security through 2FA, we'd do the same thing, I think, right? Does that make sense? I would suggest looking at it. I don't know if I've solved your question, but...
Can we do another problem?
Yeah, go for it. Yeah.
Hey, I'm Alon from Redefine. We just integrated with the Safe wallet, and we provide them pre-transaction analysis. Like every safe users, before he signs a transaction, he can see, we simulate the transaction, we run it through our policy engine, and if there is a bad impact to the user, we give an alert and with explanations why this is a bad transaction to sign. And the dilemma is how much data should we provide to the user,
right?
In order to give him explanations, but not overwhelming with a lot of information.
Yeah. So this is like actually so. I don't know if folks have noticed, but in MetaMask, for example, recently they have started to add warnings that you should, ensure that you are dealing with an entity you trust and all the rest. And they noticed a significant drop-off in transaction completion at those steps because, and this is like, a tricky thing because like that, I'm assuming for a certain cohort of people, they never saw that message before, and then now it's being put in there, and so they think there might be something actually wrong with this. So I think that, yeah, there's like an art in how to relay this to somebody, because what you're attempting to do is outfit them with enough information to make that assessment on their own, and you don't necessarily know, right? So I guess maybe my follow-up question is, in that payload, is there anything, to what degree do you ever have certainty that it is for sure bad for them?
So what we do, we have a variety of severities, like low severity, medium, high, and critical.
Yeah.
So for the critical and the high, we are really sure, and we can also like explain in English what's wrong and why you should care.
Yeah.
But I have a feeling that as long as the message, some people are not like even understand like what does this message means. Like not everyone is like crypto experts, and even if you're trying to explain to the user, I'm not sure that the user is getting the value that we're trying to provide.
This is where a lot of slow and tedious UX research and iteration basically is like the only safe path. And then like right now, where is that showing up for somebody, right? Like it's a separate plugin. It's a
no, it's on the safe.
Oh yeah, sorry, you said yeah, in safe, right? So yeah, I think like we're in this super interesting moment where because of, for example, the modularity of Safe Core, there's an opportunity for greater experimentation there. There, already is a plugin ecosystem in that we have MetaMask snaps landing, in production sometime soon, and so there's opportunities to, rather than right now where, for example, I think Revoke.cache has a browser plugin that will run kind of in tandem with your wallet and attempt to inform you about things that are malicious or suspicious that you haven't explicitly allowed listed from a certain contract address. And like parceling stuff into low, medium, and high severity is a great place to start. Then really just experimenting with the semiotics, like burying the details but making them available. And the whole lot of us working together to try and assemble a standard set of terminology to use industry-wide. Internally, a standard set of terminology to use industry-wide user-facing. Ideally that survives translation to other languages with reasonable integrity, and then also like has like example code backed UI patterns that we can all test and improve together. I don't know if anybody was around designing in or implementing in the early mid-2000s, but Yahoo UI library, back when Yahoo was like a relevant company, was an amazing resource that became a shelling point for that early phase of the industry, even pre-Ajax, pre-Web 2.0. And so, yeah, I think designing and researching out in the open as much as possible. I mean, this is kind of my pitch for the Secure Design Working Group, that hopefully more people ask those questions there. And then I don't know 100% of the work that's being done presently, but I know like 50%. And if more people keep showing up and adding to the GitHub discussions, hopefully this slowly accumulates a corpus of knowledge that like gives you an answer, or at least tells you what not to bother trying because we already did it and it failed.
Okay, thanks.
We're probably getting close to the end here. I think maybe I got 10 minutes left. Does anyone else have an authorization issue burning? Because if not, we can cycle back to these two issues and take a look at them through the lens of how to ask permission, which is this paper from 2013, I think, or 2012, done by some security researchers at Google who were working on the Android permission system back when it was very, very new, and looking at ways to escalate and manage and make decisions about requests for permission. So, 10 years later, this has been the bedrock of a lot of really interesting developments in both the Android and iOS ecosystem. And I think when we compare ourselves to Web 2 as a litmus test of whether we're hitting the mark, we should probably actually be comparing ourselves to mobile operating systems. And measuring by that standard, because they are really, really, really far more sophisticated, not yet perfect, but a better model to follow, I think. And here, if we walk through from left to right, the original notion of how you could use a decision tree to decide which permission request approach to use, you would start with, is the permission that is being, or is the action that is going to be taken with this permission revertible or severe? If it is both revertible and low severity, just automatically grant it, right? Side effects will be, controlled and recoverable. So no big deal. You don't need to ask the person for consent to use this data. Some implied consent happened from some earlier step in that case where they, hopefully they know what they're doing, putting the information on the computer itself. Past that, did the user initiate the request, or is this request rooted in some business logic, right? If the user initiated the request and the action can be altered, then we pop up what they call a trusted UI. Does anybody know this term? No. It's also a very vague term. I don't totally like it, but I could get used to using it. It basically means it's a UI that is unspoofable, that is originated from a system that inherently that user already has a trusted relationship with, right? So this is the Photos picker on Android or iOS, right? Where you know that this is as an app, I can't make it look like this is the Photos picker. One, because I don't yet have access to your photos. Two, because there's a lot of UI hints, shadows overlapping things and stuff being rendered outside of the canvas that the application itself has access to that subtly show to me that this is the real deal, right? And we don't have very many examples of trusted UI in the same way in the Web3 space, but for sure, the wallet client that you're using would be trusted UI, and dApps that you regularly interact with probably fit into that category as well, right? And then last but not least, does it need to work without immediate user approval? if the answer is yes there, that's where you would have used an install time warning, those manifests that you recall from the Android ecosystem, where it says like this long laundry list of stuff that I will be providing just by downloading and installing the app, right? And it used to be the case that as an app, you could request pretty much everything that you would otherwise ask for with pop-ups right up front, and it was sort of like the onus was on the user to like read through that and decide whether it was worth it. So you had a lot of apps, obviously, like that just asked for everything, and the moment that you downloaded them, they had basically like root authority over all your data, and they would scrape it, right? They would upload all your contacts, they would start trying to siphon your photos, they would like just do all sorts of nasty things and sell that stuff. Over the years, of course, this is being clawed back, and now even you'll notice, like in the Apple ecosystem on Mac desktop, apps will ask for access to like read and write to various directories on your computer, right? In general, it's good to inform people about stuff that the app might be using at install time, but it's good to really restrict that list. And this is something that as we go further down the path of plugins, a la what's happening in the Safe ecosystem or MetaMask snaps, like we'll really need to be cautious about what is available at those moments. Otherwise, and this is going to be impossible to read, and I won't spend time going through it bit by bit. But there is this task we've been working on at Secure Design Working Group of attempting to update that how to ask permission decision tree and make it relevant to the Web3 ecosystem that we exist in today. So where does trust get rooted to make something become a trusted UI? What kind of questions can I ask to help me determine the degree of information that I should be disclosing to somebody up front versus hiding behind show me the extra information. Breaking permission requests down to isolatable things and asking for them at the most timely moment, right? There's been a bit of discussion in the industry over the last little while about how to like pre-request details in the Dapp before you go over to the app, so that like the first expression of what is being requested doesn't just occur in the wallet client, that the Dapp itself is able to prime the person for what's going to be asked. We do this all the time in mobile phone apps, right? Like you get to a point onboarding into the app where suddenly the app is going to need your location, and the best practice there is for the app to explain why. I'll show a quick example from a different slide. So this is the pop-up that you would then see, the equivalent being what shows up in the wallet client app. But before you would get to this step, this little purpose string here would have had like a dedicated moment in the app that goes, hey, I'm about to ask you for access to your photo gallery. We use this for X, Y, or Z. When I get then pushed over to this is an example of a trusted UI, do I want to limit access to the photos? Do I want to allow full access? In the Web3 space, there are going to be different options for how you as an individual are able to attenuate that permission without necessarily breaking the experience of the app. But like this kind of moment, I don't think is done often enough right now. And that pre-request message, a lot of folks are trying to treat it up front as an attempt to emulate the the exact interface that will show up in the wallet client. And that's probably not the right path. The right path is to explain a little bit more about why this permission is being requested, if it's a spend allowance, like especially when you come into Web3 neophytes who like actually problematically may not know that this information is going to be default public on an immutable ledger, right? That they need to be informed about that. We don't actually do that anywhere in any of these flows because we know it's like, insiders spelunking and mucking around with things. So like, well, you're here, you downloaded MetaMask, I think you're already aware of what a blockchain is. As we move on to the next 10 million, 100 million people, they won't be aware of this. There's a narrative that has stuck in their heads about blockchains being anonymous, and so they think everything is private and untraceable. They do not know that these things are default public. So I think to avoid blowback when people do realize that, it's incumbent upon us to inform these folks about that part of it, to then inform them gradually as they onboard and need to take actions, what those are going to be, and then kind of work towards standards that will show up in the wallet clients themselves to make that like receiving part of that action in the trusted UI of the wallet client far more legible. We're done. We can take more questions, or we can talk outside while drinking delicious white wine or something like that.
Thank you.
You're welcome.